Okay, good. So this is the normal distribution practice that you sent me on. I haven't finished marking it fully, so let's just go into it. I think I've checked the first 7 questions only, and you have a problem with question 2G over here, right?
Yeah.
Okay, let me show you how to do it. So over here, you're starting off with x being a normal random variable, mean 67, and what's 89? Can you tell me what is it? What does 89 refer to? This guy is called sigma, which stands for the...
Is the variance.
Very good. So it's sigma, but you need a
Square.
Square. Yes, sigma square. Oh yeah, by the way, I sent you what is it? I sent you on Telegram, right? Something. What did I send you? I sent you a link to our calculator, a bell curve. I made it myself, and what do you call that? Example of a question. We'll go through it later.
Oh, okay.
Yeah, for now, don't need. Okay, so yes, it is sigma square, which stands for the variance. The sigma itself is standard deviation. Does this make sense to you?
Yeah.
Can, huh? So variance, you just variance is sigma square. Standard deviation, you take the square root. In the calculator, when you want to calculate normal CDF, do you want to use you key in mu and sigma? So does sigma refer to the variance or the standard deviation again?
The standard deviation.
So if you are given 89 here, can you key in 89 straight away in the calculator?
No, must be square root 89.
Very good, exactly. Okay, keep that in mind. I think that was the problem in one of the subsequent questions. P of k less than x less than 90 less than 0.111. You need to use a GC for this question. But before that, what you need to know is that for probability, you can always split it up into 2 guys, but subtracted. Okay, how does the graph look? Actually, when you have 67, 89. Okay, let me just let me show you on that link if you can click it.
Okay.
Yeah, go click it. Let me share this screen. Okay, so here is the what do you call this? The probability density function of this bell curve. Hold on a second. Mean is... That's correct. Okay, where is my graph? Where did it go? Quick. Oh no. Okay, I need to change the scale, I guess. There it is. Okay, I zoom in too much. Okay, so can you see the graph?
Can
I? This is the bell curve. Take a look at what happens as I move. I know there's a lot of things going on here, but just need to know our bell curve is really just a function. Okay, when I change the m value, m actually stands for mu, s stands for sigma, or mean and standard deviation. Look at what happens as I change my value of mu. Ooh, can you see what's going on?
Yeah.
As the m gets bigger, what happens to your graph?
Shifts to the right.
And of course, as it gets smaller, it moves to the left. But more importantly, I need you to notice that if let's say m equals 1.2, if I draw in a graph x equals 1.2, what do you notice? It cuts the graph directly into half. Right? 2 equal halves. Yeah. Can you remember this idea or not?
Can.
Okay, can maybe I change it more fancy. X equal to a. Then after that, I change this to x m equals to a as well. Then I add a slider for a. Okay, so you can see the graph moving along with that satay stick. The bell curve is like a stingray. It's like a sotong, and then the blue one is like a satay stick. I hope you can visualize that. Okay, let's resume. Okay, so yeah, don't need so much of fancy graphs, just draw a sketch like this. So what we currently have is x following a normal distribution with mean 67 and standard deviation 89. So here it's your mean. Just now I use letter M equals 67. It's the line of symmetry, vertical line of symmetry. Can you see that? Okay.
Yeah.
Then when we ask you to find probability k less than x less than 90, what we mean is there's a value k here. I'm not sure where it is actually. Okay, eventually we will find out that it's 78.2 to 90, which means that k should actually be bigger. But I don't know for now. Let's pretend that I didn't know that. Then I put a k on the left. And then I mark out another 90 on the right. So what they're asking me to do, they are really, when we ask for probability, they're really asking me to find the area underneath the curve. Okay, so we can find out this part here. Okay, that is what probability refers to. It's the area under the bell curve within these boundaries. You don't need to do that. I know you're thinking, what you're thinking, maybe you're thinking of integration, right?
Yeah.
Find area under curve. But in probability, that will be too difficult. In fact, even in university, it is still too difficult. You can only use a computer to help you to find the area. So that's exactly what we are doing in A levels. Just use GC, which is the computer you have. Actually, I also realized something. I need you to realize something. This guy here, if I just find the area towards the left of 67, what would this be equal to?
Half.
Very good. And the other guy, other half is also 0.5. So add together gives you 1. Does it make sense?
Yeah.
Can Okay, good. So actually, I also realized that here the probability is less than 0.111, which is less than half. Right or not? So that means my k value should be somewhere else. It should be a bit more to the right, so that I can have an area, the blue area, to be less than half. Does it make sense? The 90 is definitely to the right of 67, but your k must be somewhere here already. So your blue area is actually over here. Does it make sense, this part?
Yeah.
Just without even doing any calculation, I know where's my k value already. It's roughly between 67 and 90. It cannot be more than 90, right? If it's more than 90, what happens? There's no area, There's no area. The left guy must always be smaller, right guy is bigger. So that's why you have the first part of the answer is k less than 90. Does this k less than 90 make sense?
Yeah.
Okay, before doing any calculations, you should know this k less than 90. I mean, okay, by comparing with this 0.11 versus 0.5. Right? Okay, so now how about this part here? K more than 78.2 or 78.2 less than k. This is when you need to do a bit of algebra already. Here, whenever you got probability, what we call a chain inequality, you can always split it up into x less than 90, then x less than k. How do you visualize this? X less than 90 is referring to this area here that I'm coloring in green. Can you see that? This entire area? Okay, I'm not going to shade it in. It's a bit messy. Then how about this part here, x less than k? What does it refer to? It's referring to this area here that I'm highlighting in purple. Can you see?
Can.
Shade in and then I remove. Okay, so what happens when you take green minus purple? What are you left with?
The k to 90.
Correct, the blue color area. Does it make sense now?
Yeah.
It will follow the same pattern every time. So in general, P A less than X less than B. Like for example, in this case, B is 90 and A is the K. You can always split it out as X less than B minus P of X less than A. P of X less than B minus P of X less than A. The green area minus the purple area. This is a standard formula you need to know. Is it okay?
Can.
Can, right? Then that should be your first step. You don't try to make it into modulus X. I'm not sure what you're doing. Should split it up into a minus. Okay, so left-hand side substituted already. Then let's carry on. What do we want to solve for? We want to solve for k, right? So that means that every time you want to solve for k, you want to make leave k alone on one side of the equation. So that's exactly what we're going to do. Of course, the minus p of x less than k, we're going to leave it alone. This green color p x less than 90, bring over. It becomes a minus. Of course, you can calculate the value later, but that's not so important. We continue making the format of the inequality a bit nicer. Here I got negative. Actually, at this stage, you can type in a GC, but I prefer to convert it into positive. So I multiply by -1 on both sides. Can you see? Positive 0.11 become negative. Negative becomes positive. Okay, but then what happens to your inequality? Multiply by negative, you need to flip
Reverse the sign.
Correct. So more than. So now you either use a GC or a table of values. Okay, table is outdated. Don't need. Just use GC, you can already. Okay, so how do we use the GC to calculate this? Let me show you on the screen now. So let's turn on the calculator. Did I already draw it? Never mind, I reset. Okay, so how do we deal with this P of x less than k? First, you need to remember what is x. X is following normal distribution. Let me see. 67,89. Just to make it more obvious, I take square root, then I square. Square root, then I square. Why? Because I need to do that in a calculator. So P of x less than k is what I'm going to key into my y1. If you remember what's y1. Y1 is here, the first equation. Then second, distribute normal CDF number 2. Then you go from x less than k means negative infinity all the way until a letter k. Of course, I use a letter x variable. Then we let the GC find x for us. Then mu is what? 67. Sigma, is it 89? No, it should be
89.
Exactly. Close the bracket and paste. So that is y1. We need to make it more than P of x less than 90 minus 0.11. Oh, this part here. This part here. So we're gonna key in this part in the calculator as well into the GC. Okay. So let's just do that. So Px less than 90. Change the x to a 90. Everything else can remain. And then you subtract away 0.111. And okay, don't need enter, just draw the graph. And we already know our answer is expected to be between 67 to 90, right? So that means we should change our scale. If it's graphing too slowly, you can press on to stop it. Press on, then you'll stop it.
Oh, but I haven't graph finished, never mind.
Yeah, because it's not gonna give me the answer. Because look at my x scale, 0 to 10.
Oh, okay.
Definitely the answer is not there. So I just change it to 67 to 90. Should I change my y scale? Not sure. We'll see. We'll see how. It's still quite slow. So I'm just going to press the window. Do you remember the strict X res?
Yeah.
I change it to 8. Lucky number 8. Then the graph will be hopefully faster. Okay, I can't see anything. What does it mean? The y value is 0.9. 0.9, but my scale is only until 0.2. So I guess I should change it. Maybe I'll just change it to 4 or something. Okay. There we go. Okay, something slightly nicer. Can you see?
Yeah.
Blue and red. Okay. Okay, and then second, calculate. Find the intersection. Because we just need to solve for k. So first curve blue, enter. Second curve red, enter. Guess, yes, press enter to solve. Wait for it a bit. Finally, it loads. The answer is x equals 78.161359. Okay. Now, so using GC, we get k to be approximately 78.161. Okay, blah, blah, blah. And then finally, you can answer the question. The range of k must be in between 78.2 less than k less than 90. Round off to 3SF. Is that okay?
Yeah, okay.
Can Okay, good. 2G done. Moving on. What was the next question? Question 4. Okay. Question 4. Okay, let's take a look at this question. So part 1, part 2, part 3. So for the first part, hen minus a less than y less than hen plus a, they have a random variable y which is normally distributed with mean 10 and variance 4. So that means that this part is okay, correct. Then how do you solve this? You split it out as y less than 10 plus a minus y less than 10 minus a. That is actually a good step. However, for this question, might not be so useful. Because there's an unknown a. Actually, this question, right, A. I don't need standardize. No, sorry. Cannot standardize. You don't know the value of A. You can just use a GC. Yeah. Do you know how? You don't even need to split this up. Let me show you how. Huh? This
Okay.
A is representing, it will just be the X or unknown X. And we'll let the GC solve it for us. Go back to Y equals, clear. Or whenever there's an unknown A and you want to replace it with an X, right? Just use the Y equals, draw the graph. Okay. Whenever there's an unknown A and you want to calculate the value of A, then just let that be the random variable X, all these X, then you can just replace the A with X. So how do we calculate that P of 10 minus A less than Y less than 10 plus A? Just go to second distribute normal CDF. Lower limit is what? 10 minus X. How about upper limit? What do you think is upper limit?
The 10 plus X.
Exactly. Then the mean and variance, you know how to key in. 10 and, sorry, not variance. It's square root of variance. So this should be 4. Square root of 4, 2. Is that okay? Must have a square root, huh?
Yeah.
Okay, then paste it. This is the left-hand side. This is what we just keyed in is the left-hand side, P10 minus A to 10 plus A. All right. We want it to be equal to 0.95. So we draw the graph of 0.95 up, which is a horizontal line. Then we just draw the graph. Let me just change my scale. Make sure I can capture 0.95. So I only need until intersection with a horizontal line 0.95. So maybe I'll just go to 1.2 or something. I don't even need negative. I know it's 0.95. So how about 0.9? 0.8? I don't know. So it can be centered. What's the X value? Let's look at the solution first. 3.9. Okay. Then we'll just change it from 0 to 10 to make the graph look nice. Draw the graph. Just nice. It intersects there. So you can find the solution. Second, calculate. Number 5 for intersect. First graph, second graph, guess. And you get the answer to be 3.9199256. Okay?
Okay.
Yeah. That's all to the using GC. Then how about a second way? I think that's what the solution gave us. What they did was, okay, wait, hold on. Let me just go to the solution now. Yeah, so method 1 I already explained. Now method 2, what are they doing? First step is to draw the graph, a rough approximation of what we call the PDF, basically the bell curve. The bell curve. Then the mean we know is 10, right? Recall what was X again? Sorry, Y. Random variable Y follows normal. Mean 10, variance is 4, so 2 square. All right. Then I hope you know that the mean, the line of symmetry is X equal to 10. So that means that when we try to find a P of 10 minus A less than Y less than 10 plus A, 10 minus A, 10 plus A, they will be symmetrical about the 10. So that means we're really finding out this area here, a symmetrical area. And that area is 0.95 because that's what's given. Does this make sense?
Yeah.
And now the graphical interpretation. Now, since we know this is symmetrical, can you tell me what about these other two areas on the left and on the right? They will also be
The same.
the same, exactly. And what is that area? That will be, if you just do some quick calculation, the total area under a curve is 1. The shaded area in between is 0.95. So that means the area that's remaining must be 1 minus 0.95, which is 0.05. So let's just fill that in. Pink color shade arrow 0.05 over 2. Sorry, I have to divide by 2. Why do I divide by 2?
Because it's both areas add together.
Correct, exactly. Okay, so now we can always reinterpret this question to a different scenario. Let's think of it as a left tail area. This would be, in other words, it's P of the single random variable on the left-hand side, just for y, strictly less than question mark equals to question mark. What do you think can be possible values for this question mark?
No, 10 minus a.
Here, 10 minus a. 10 minus a will be here. Then, okay, let's do that. What else? How about then, in that case, p of y less than 10 minus a means what? Means the area from 10 minus a all the way towards the left. You see the arrow pointing to the left? So you also find the left tail area. Is that okay? Oh, right, I forgot to mention this GC I'm using is the older version. It doesn't have the left equal or right when you're calculating CDF. Your GC should be the new one, right?
Yeah.
It has a left equal or right. The older models of GC by default, and that is the only option available, is finding left tail area. So yeah, that's why I will usually always standardize into left tail. It's my habit, because that was how I was trained. But now modern technology, you can automatically calculate more than you don't even need to think anymore. 1 minus to make it into left tail area, don't need anymore. Yeah. But just to let you know, less than means left tail area. If it's y more than, then it becomes right tail area. Right? Maybe a right tail area. From a vertical line, you move towards the right, the area towards the right, but still underneath the curve. Okay, so what's on the right hand side then?
The 10 plus a.
Wrong. No. You don't understand this part. P of y less than 10 minus a means P of this guy means the area less than 10 minus a.
Is the 0.05 over 2.
Very good. That's better. Okay, that's one way to do it. There's another way. I hope it's not too small. You can see. Another way is P of y. Let's say I want, I don't know, less than 10 plus a. What would this be equal to? 10 plus a is this guy. Less than that would be what? This area all the way. What would this area be?
Is 1 minus 0.05 over 2.
Yes, correct. 1 minus away the right-hand side area. 1 is the total. You chop off the right side. Then you're left with the left side area. Alternatively, you can just take 0.95 plus 0.05 over 2. It will give you the same answer. Okay? Yeah. Then from either of let's just follow the answer key solution, which is this format. Then how do you solve for a in this case? You need to take inverse norm. Okay. Here you can do inverse norm in order for you to find out these x values. Does it make sense? Let me just demonstrate. I think it will make more sense. Okay, I'll press turn on. Second, quit. Just go back to the main page. Then second, distribution, scroll down until you find inverse norm. Enter. Then area will be what? Area will always be the right-hand side value, the probability value. P of whatever equals to this number on the right side. That's your area. That's your area. Okay, then the mean is what? 10. Then the sigma is what? Can you tell me what sigma? Is
the square root 4.
Square root of 4, which is 2. Okay, I purposely rewrite as 2 square over there. You can see the 2 square. So that the square root of 4 is 2, because square root of 4 is 2. Okay, then just paste, enter, and you get your answer for 10 minus a, or 10 minus a, okay? Let me, no space. Bring this down. This is same scenario. Okay, but here, using GC, you're able to solve for 10 minus a to be 6.0800. 7. Okay, then in that case, if you want to solve for a, just take 10 minus, which will be 3.91993, right? Okay, then that's exactly what they got, then 3SF. Okay. Is that okay?
Yeah.
The decimal is different. never mind lah, doesn't matter. 3SF still the same. The accuracy at the back, it may not be the same because of some rounding error. It's fine. Okay, part 1. Okay, moving on. So okay, just a recap on what is area again. P of x less than k means you draw the bell curve, then you have a vertical line x equal to k, and you find the area, the shaded region towards the left. We also call this the left tail area. Left tail area. Then the other guy, P of x equal to k, because x in this case we're discussing about normal distribution, right? So it's a normal random variable. It's under a special kind of random variable, special class of random variables known as continuous random variables, as opposed to like binomial distribution, which is discrete. Like x takes on the number of hits you obtain from flipping 10 coins, right? The number of hits is discrete, right? You can't have 2.5 hits or 2.3 hits.
Yeah.
So, but here x is referring to let's say the mass of flower petal. You measure the length of many flower petals, and then you calculate the length. Then you let x be the random variable that takes on the values of those lengths. Length can be anything, right? 2.1 cm, 2.2 cm, 2.21 cm, 2.22001 cm. So that's continuous. Does it make sense?
Yeah.
In here, and when it's a continuous random variable and you put equal sign, the probability will always be equal to 0. Is that okay?
Yeah.
Because probability is area under a curve. X less than k means negative infinity less than x less than k, which means it's from all the way to the left towards k, and you find the area underneath. If it's just x equal to k, it means that your area is from x equal to k to x equal to k. There is no area to talk about. So that's why it's 0. So P of x equal to k equal to 0. This guy equality is not very relevant for continuous random variable. Okay?
Oh, okay.
Good. Then next, what we have is x more than k. It's just the opposite of right tail area. But you must also know that this is exactly equal to 1 minus px less than equal k. Px more than k is the same as 1 minus px less than equal to k. But the equal sign doesn't matter. Why? Because x equal to k is just 0. It doesn't contribute. Okay, so this is actually also exactly the same as 1 minus px strictly less than k. Can? Okay, good. Now moving on. Part 2 done, right? No, part 2 not done. Probability that y is between a and 12 is 0.15. So let's just read the solution. A less than y less than 12 equals 0.15. So they split it up straight away. Oh yeah, by the way, just now the first step, first question, we didn't try to split up because when you split it up, what happens? Let's see what happens. Py less than 10 plus a minus py less than 10 minus a. The problem here is that the a appears in both probability expressions. Right, it appears in both. That's very problematic. We can't really proceed. Okay, we want to keep the variables limited to one side. Then we can take inverse norm. Is that clear? Like, okay, look at what we are able to solve, this format. What's so special about this format? There is only one single probability expression and one single unknown a. Compared to the other guy, you have probability unknown a in two separate terms. When it's two separate terms, we can't inverse norm. Right? Only when it's a single p bracket. When just one single p bracket, then we can inverse norm to find our answer. Please remember this idea, okay? One single p in this particular format, then we can take inverse norm. All other formats, case by case basis, probably most likely cannot. Okay? And must know when you can use inverse norm. Should I write this down formally? Okay, maybe I should write this down. Yeah. If we got p of, I use a different color. When you have p of x less than some q equals to some area, let's just call it a. Okay, you know what? Yeah, A is fine, A for area. Then if you want to solve for Q, Q will just be equals to inverse norm. Inverse norm of dot dot dot. You can fill in the details on the GC. But what is important to take note of here is this format, it must be strictly followed. One only. 1P. 1 unknown. Okay, maybe the right-hand side can also involve Q, but usually it won't. Maybe I shouldn't mention this. I should just say one single P only. Okay, this particular format, then you can take inverse norm. Is it clear now?
Yeah.
Just one single P. Yeah. As compared to a case where you cannot take inverse norm. This is the example. P of something minus P of something. Two different terms cannot take inverse norm. When there's unknown. But here, how come they decide to split it up in part 2? Wouldn't there be a problem in taking inverse norm? You see, there's two P's. Here, it's actually fine. Why? Because P of y less than 12.
It's
actually
like a
just
number.
A number. Then you can just bring over, right?
Yeah.
So if you bring over, you end up with this bunch of numbers equals to 0.69134. Here, there's a minus sign, so they also multiply by negative. I think so, yeah. Or you can think of it as minus, bring over, become plus, then the 0.15 plus bring over become minus. And then they swap the sides. So Py less than 12 minus 0.15. Is the algebra here okay?
Yeah. But why is less than or equal to?
Where? Which part? Oh, this part. Okay. Honestly, it doesn't matter too much because this is a continuous random variable. If this was discrete, then yes, it will matter. Like let's say if you have a x that's following binomial distribution 10, 0.5, you flip 10 coins, head or tails probability 0.5, 0.5, then P of, I don't know, like 3 less than x less than 12 would be the same as P of x less than 12 minus P of x less than or equals to 3. Yes. That's why there's an equal.
But just now that question, we never put the less than or equal to.
We started yeah, but you mean this part and this part, is it? Or is it the 2G?
The 2G, yeah.
Okay, let's take a look at 2G. You put an equal sign. Okay, actually, technically you should, but this is a continuous random variable, so it doesn't matter when you put the equal or not.
Oh, okay. But will they like mark wrong?
No, they will not mark you wrong. Okay. Just to take note, P of x less than or equal to k is referring to probability that x is exactly equal to k or x is strictly less than k. These are what we call discrete sets. Yeah, sorry, not discrete. What do you call it? Disjoint sets. So mutually exclusive. You can always add the probability of each event separately. Okay. Then what is P of x equal to k? I just told you is 0. So that's why you get 0 plus P of x less than k. That's why they are always the same. This guy and this guy are the same.
Oh.
So you don't need to put the equal sign.
Cool. Okay.
Okay. And for continuous random variable, normal distribution. Okay, your syllabus only deals with normal distributions. There's a lot more continuous random variables. You will learn more about it in the future if you have to take statistics. Gamma distribution. Yeah, never mind. Don't talk about it. Okay, not relevant to H2. Yeah, so where were we? Yes. This part, they put an equal sign. It's fine lah. You don't even need the equal sign. You can just throw away because this is a continuous random variable. So in that case, solving using inverse norm, you get 10.999. Do I need to show you this? Maybe I'll just show you lah. Just to be safe. Let's take a look at inverse norm number 3. Then what is y again? y is 10 2 square. So the area what we have on the right side. Area what we have on the right side is 0.69134. Okay, I'll just take their value. And then the mean is 10, the variance is square root 4, paste. 10.999. Okay, is that okay?
Yeah.
That's how you get the A. Okay, that's good. Let's move on. So they gave you an alternative method. It's the same thing. It's really the same thing. They just changed the direction.
Oh.
Okay. I'm a bit confused by what they're doing. Why did they change the direction? I'm gonna ignore this one. Yeah, it's non-standard and ignore it. Okay.
Okay.
Can all right, good. Moving on. Part 3. Part 3. But before that, two independent observations of y are denoted by y1 and y2. Find part 3, p of y1 plus y2 more than 18. So over here, what you need to realize is that since they are independent, that means we can just combine them together and we'll still get a normal random variable. y1 plus y2, the distribution will still be normal. Okay? Is that clear? So that's what we're going to do now. We know that they will still be normal. So then we can go on to use our normal CDF, inverse norm if we want to. So let's just calculate what is the mean as well as the variance of this resulting y1 plus y2. And you did the working. You calculated the mean over where? Over here. Oh?
Yeah.
I think so. Not this question. Sorry, this question. You calculated the mean, that's fine. But the variance here, you also calculated. But what I believe you did wrongly was in typing the calculator, you forgot to take square root 8. You forgot to take square root of 8. Let's summarize what you have. Your result is correct.
Oh.
Do you? And also, wow, what kind of notation is this? What kind of notation is this? Illegal. What's wrong?
Cannot.
Y less than blah blah blah. Y less than blah blah blah. Y1 plus Y2.
Oh,
what's my
less.
inequality?
Oops.
Never copy question correctly. So more than 18. Okay, more than 18. So more than 18. Let's just demonstrate on the calculator. So how? Second distribute, go to normal CDF. More than 18, right? So lower limit is 18, upper limit is infinity. We can type that by typing in E, double E here, the blue color. Second comma is the E, and 99. Of course, if you find that a bit too difficult, you can always type 10 to the power of 9. Same thing, or 999, whatever value. Let's just make it a bit bigger, 99 is good enough. Then mu is what? What's mu?
The 20.
It's 20. Okay, good. So we can key in 20 here. Okay, and then what is the sigma?
The square root of 8.
Square root of 8. 0.76. Right? How do you get the 0.59?
I think I keyed wrong.
Let me predict what you did. I suspect you didn't change the direction. I'm not sure. I'm just guessing. Because this one, the direction is of the arrow. Look at it. It's y1 plus y2, strictly more than 18. If you keep this in, you'll get the wrong answer. It's still wrong. Okay. Or is it because you forgot to take the square root? Okay, let's double check. Try and figure out what's your mistake. Yeah, you forgot to take the square root. Yes. You are typing in this 18 to 10 power 99, 20, 8. What does that mean? Means lower limit 18, upper limit 10 power 99. mean is 20, sigma, you take it as 8 instead of square root 8. Okay, so the mistake here is just forgot to square root the 8. Okay, yeah, that's all. Then the rest is fine. Okay, moving on. Part 3, part 4. Okay, what's the next question? Question 6. Yes. Can you go to that Telegram question I sent you? Okay, I'm gonna try and add in an extra page. Where should I put this? I'll start a new note. Okay. Normal distribution. Okay, hold on a second. Let me go and get the question. Resume. Can you see my shared screen?
Yeah, can.
If I try and make it small. Okay, good. So here's the question. Example that involves an unknown mean and an unknown variance. How do we solve this question? First step is to write down the normal distribution for x and fill in the blank mu comma sigma square. Is this okay?
Yep.
Yep. Then you have px less than 8 equals 0.05. How do you proceed? Can you calculate px less than 8 when you don't know the mu and sigma?
Cannot.
What do you need to do then?
Standardize.
Correct. So z equals to x. What's the formula?
X minus mu over sigma.
Correct. And it follows this guy, the new random variable z, it follows still a normal distribution. So n. But what's the mean and what's the variance?
The 0 and 1.
Very good. 0 and 1, standardization. You can prove it. I am not going to prove it to you. Please just memorize this. Most efficient way. Okay. You can go and calculate this by taking expectation of x minus mu over sigma. Given that x follows normal of mu comma sigma square, which means that expectation of x equals to mu and variance of x equals to sigma square. From these two, you can prove that E of this guy is 0 and the variance of the other guy is 1. Can be proven. You can do it in your own time. If not, just memorize this. How do you use it? That's more important. How do you go from this into the standardized form? Here's what you do. I'll copy down the P, the less than symbol, x and 8. When you minus, what you're gonna do is you're gonna subtract away the mu. In this case, the mu is unknown, so we just write down mu. If you minus on the left, you also minus on the right of this inequality here. Can see or not?
Yeah.
Then if you divide by a sigma, you also divide by a sigma. Okay, so remember the procedure of minus mu divide by sigma. Okay? Here we minus. Do we need to change the direction of the symbol?
Don't need.
Don't need, because this is subtraction. Only multiplication or division by negative, then you'll need to flip. Then here we divide by sigma. Do we need to change the direction of inequality?
No, because it's like positive.
Very good. Sigma by definition is always positive. Sigma is more than 0. Sigma is the square root of the variance, the positive square root. By definition. So need to memorize. Okay, it's always positive. But wait, what's x minus mu over sigma? Over here, it's equals to z. So we can replace that left-hand side with a z. Is that clear? The left-hand side replaced with a z?
Yeah.
So step 1 is minus mu. Step 2 is divide by sigma. I should write this down. Okay, then after that, the right-hand side can't do anything. Leave it alone. Is that okay?
Okay.
Good. Then for the second procedure. Okay. At this stage, we can take inverse norm already. Why? Because z is now a normal distribution. We know its It's a standardized normal distribution. We know its mean and variance, or standard deviation for the purpose of keying into a GC. Is that okay?
Yeah.
Then we're gonna take inverse norm. From here, we can find out the 8 minus mu over sigma's value. So let me just show you on the calculator. Make sure that the inequality symbol here is pointing to the left. It must be of this format. P of a random variable x less than some q equals to some area. Inverse norm. Then you will get q equals to whatever. Here, random variable on the left. Maybe I should describe this RV. And this one is a value, some number. Then it must be less than symbol. Must be a less than symbol, or less than or equal. Cannot be more than equal. And then there's a single value on the right side. Is this okay?
Yeah.
Very good. Carry on to GC. Second distribution, scroll down to inverse norm, enter. Area is what? 0.05. Then what's the mean and sigma? It's just 0 and 1. Technically, it should be square root of 1. Correct? Variance is 1. So square root of variance will give you standard deviation. But obviously, square root of 1 is 1. So we leave it alone. Is this okay?
Yeah.
Okay, and paste and enter. Then you get your answer. Copy down. So that means that we can actually multiply the sigma over, get 8 minus mu equals to this guy times sigma. Let's just try to make it look nice. I'll bring the 1.6448 sigma to the left-hand side. Minus mu equals to negative 8. Okay? Okay, now just a bit of algebra. Okay, now that is for the first part. Of course, we have a second piece of information here. Px more than 15 equals 0.1. Do the exact same procedure, but with a twist, because now it's a more than, so you have to be careful. Can you recall what's the procedure? Inverse norm straight away?
No.
Cannot. Inverse norm need less than symbol. Here is more than. What should we do first?
Change to 1 minus p x less than 14.
Okay. Sorry. Very important note to take note of here. More than 15 opposite is actually less than or equals to 15, not 14. Right?
Oh.
Not 14.
Yeah.
Even if it is a discrete distribution, right, it will still be less than or equal to 15. Is that clear? Not 14. If it is p of x more than equals to, let's say 17 instead, this will be equal to p of x less than 17. That's correct. Or if this was discrete, if x discrete, like for example, the only discrete distribution you're learning in your syllabus here is binomial. Then you will say x less than or equals to 16. Yes, that's okay if it's discrete. But before that, you should know the opposite. You should just keep the same number, then change the sign. Inequality symbol. More than equal become less than. That's the opposite. 1 minus the opposite. So more than the opposite is what?
Less than or equal to.
Or equal to. Yes, right, correct. Okay. But here, because it is okay, so that's just a side note. But here, because this is what we call a continuous random variable, normally distributed, what do? The equal sign. You can just toss it away. Toss it away, it will still be the same. Because this guy is really just p of x less than 15, add on p of x equals to 15, which this guy on the right side is equal to 0. So you can just ignore it entirely.
Okay.
Yeah, so now how? Continue. P of x less than 15, I hope you can immediately calculate this as 0.9. Right?
Yeah.
1 minus, if this is 0.9, 1 minus 0.9 gives you 0.1. Okay, good. Then how to continue? Inverse norm, right?
No, must standardize.
Because x, we still don't know the mean and variance. So we need to standardize. So how to standardize? You can skip a step, jump directly to z. Then what's on the right side?
The 15 minus mu over sigma.
Minus mu over sigma, minus mu over sigma. Repeat until you can say this very fast. Minus mu over sigma. Okay. Then how about the 0.9? Do we need to minus mu over sigma as well?
No.
No, only the inequality gets modified. And the inequality is inside this probability expression. Okay, so now we try to calculate. What do we do now? Take the inverse norm. Okay, this one is called standardized. You don't need to draw the arrow, it's just for your note-taking purpose if you need it.
Okay.
15 minus mu over sigma will be equal to, I'll just show you. Second, distribute. Go to inverse norm. Area is on the right-hand side, right-hand side constant, 0.9. Mu and sigma is standardized to be 0.1. Enter. That's your answer, 1.28155515. Okay, I don't write so many decimals, if not my hand pain now. Okay, anyways, this guy, let's take a look at the previous guy. We got sigma on the left, mu on the right. So that's equation 1. Okay, first equation in terms of two unknowns. Then we have our second equation in terms of two unknowns. So what do we need to do now? Use simultaneous equations, right? But before that, we need to make this in the same format. Oh?
Wait, for the P is more than 15, right? Can I just use the right tail test?
Right tail. This part here?
Yeah, like I don't minus.
Oh,
if like I'm lazy.
Does your inverse norm have the left tail, middle, equal, and right tail?
Yes.
Then can
Then
also.
it's the same.
Do you get
Okay.
the same answer? Can you try?
Yeah, it's same.
1.28. Okay, can also.
Okay.
All right. Can good.
Mm.
So now we can multiply the sigma over. We get 15 minus mu equals to 1 point whatever times sigma. Then what do I have? I have a sigma on the left followed by mu on the right. So I should do the same thing. Maybe my minus mu bring over. Then I'll be left with this sigma plus a mu equals to 15, equation 2. So what do I do now? Solve 1 and 2 simultaneously. Okay? Let me show you different calculator. Just show you both calculators, I guess. Let me share screen. Okay, good. Now we have two calculators. Okay, let's try the scientific calculator way. I know it's a bit different. The model is a bit different from yours, but should be something similar about number 5 for equation.
Yeah.
Then you can choose simultaneous equation. Here is anx plus bny equals cn. That's two variables, x and y. Number 2 is for solving 3 equations, 3 unknown, x, y, z. Here we just choose number 1. Then just fill in the blank. So equation 1, we have a 1.6448. Then equal. Then b is -1. Equal, then -8. Equals, and then the next one is 1.28155 equals +1 equals 15 equals. Is that okay?
Yeah.
Yeah, then after that you just press equal and you can solve already. So that is the x is your first variable on the left, which in this case we have chosen to be sigma. Let me copy down first. Later then I show you the screen. I can't show everything all in the same screen. Then the next one will be mu equals to 11.9344. Okay, can? Now let me demonstrate on the GC as well, since I got both calculators. So press APPS, then go to Poly Simultaneous 2. It may not be number 6 on your calculator, it depends. Okay, then this is the older version. So you just pick simultaneous equation solver. How many equations? 2, 1 and 2. How many unknowns? Mu and sigma, 2. Then you press next, and just key in the matrix. It's the exact same procedure. 1.6448, that's for your coefficient of sigma. No. Enter. Then -1, enter, -8, enter. And I hope you notice that there's a solid vertical line there. Oh, right. This solid vertical line is supposed to represent the equation, the equal sign. Okay, it replaces the equal. And the next one will be 1.28155 sigma plus 1 mu equals to 15. Is that okay?
Yeah, can.
Then solve. You get the same answer? Okay, very good. Okay, here you notice that there's a fraction, so you can press this button. F/D means fraction to decimal. It's a toggle. It will switch in between the two. Okay? Can?
Can.
Okay, good. Let's just remove this and carry on. Hold on a second. Let me see. How do I? Oh, right. Okay, can. So yeah, when we solve for mu and sigma already, that's all. Round off to 3SF. So 39, 11.9. Okay. Can. Good. Now that you know how to do this, we can move on to the actual what do you call this? Actual EJC tutorial. It's the exact same thing. What's the question number again?
6.
Question 6. Okay, let's go to question 6. Yeah, so over here they are just making it a bit more sophisticated. By giving a context before you do that question that I did just now. Observations are made of the speeds of cars on the Penn Island Expressway during the peak hours. It is found that on average, 1 in 20 cars is traveling at a speed exceeding 90 km per hour, and 1 in 10 is traveling at a speed less than 60 km per hour. Assuming normal distribution, find the mean and standard deviation of this distribution. Random sample of 100 cars is taken, find probability that at most 18 cars will be traveling at a speed of less than 60 km per hour. So there's two parts to the question over here. We'll deal with the second part later. We focus on the first part. On average, it's just telling you it's probability. 1 in 20 is a probability, 1 out of 20. Okay, traveling at a speed exceeding, I hope you can think of inequality, right? More than 90. So speed, then what do you always have as an inequality on the left-hand side? A random variable, right? X.
Yeah.
More than 90. So, but here the English word is speed more than 90. So what do you think is X now, the random variable? It has to be speed. Makes sense, right? Just translating the English into the math.
Yeah.
Speed exceeding 90, X more than 90. So from there, you know how to define your X already. Let X denote the speed of a car. Then this one just copy and paste, blah, 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 whatever. Not important. Speed of a car is the main point. This is the context. Okay, context is important. Yes, it's important. But you can just copy and paste from the question. Okay? So then it must follow a normal distribution because they are already mentioned here, assuming normal. Is that okay?
Yeah, can.
Can. So yeah, let's just translate this in English into words. Probability 1/20. So that means it's 1/20 on the right hand side. Speed exceeding 90. So that means it's X more than 90 over here. Probability equals X more than 90 equals 1/20. And can we proceed with this and inverse norm or anything? Not really, because we don't know what is mu, don't know what is sigma. We also cannot calculate the probability here in any usual way. So that's what that's why we have to standardize. Do you understand the procedure here? Minus mu divided by sigma.
Yeah, I think my answer is correct. It's just for like the second part of the question. I cannot really.
Oh, you got the right answer.
I cannot really actively identify the normal, like suddenly switch to binomial, then I don't know is binomial.
Keyword. Random sample of 100. N equals 100. they don't need to provide you. If this was still a normal distribution question, why would they need to give you this? Don't need. So the moment you see random sample size of 100, or you could think, is it doing hypothesis test? Definitely not lah. They never give you a hypothesis test at all. So it must be binomial distribution. There's only two possibilities. You see random sample of 100, n equals 100 lor. And then they tell you probability that at most 18. At most 18, I hope you can translate this into less than equal 18.
Yeah.
Right? So you probably need to introduce a new random variable y to represent what? Number of cars traveling at a speed less than 60. This is the maybe traveling at a speed less than 60. This is the event of interest. Then here they tell you at most 18 means some random variable is more than or equal to 18. So what do you think is y? Let y be denote the what? Let y be random variable denoting the
number of cars traveling at a speed less than 60 kilometers per hour.
Exactly. Yes, number of cars, right? The general version of 18, at most 18 will be number. Then what do you want to do with this number? The y. You want it to be more than or equals to 18. Make sense?
Yeah.
So now that means that you either number of cars, right? So it's either traveling at a speed less than 60 or not less than 60. So there are two what do you call it? Disjoint events or mutually exclusive events. And the probability is fixed. The probability of this optimal outcome, the success and failure. This is the success. Maybe I should just call this the success event. Yeah, don't say event of interest. Just say a success event. Right, the success event. So then from there you can tell that you will almost satisfy all of the criteria for you have already satisfied all three criteria needed for binomial. You got a fixed n number of trials, and they are independent of each other. Okay, that one we have to assume. You have to assume that they are independent. Assume independent. Like then you have a successful event, having a car traveling at a speed less than 60. There's a fixed probability, P. And then if it's a failure, then it will be 1 minus P. But wait a minute, and okay, hold on. We also need one more condition. This P here is a fixed number. But hold on, what's P? What's P?
Is unknown.
So that's when we need to calculate it. So what is this P referring to? The probability of the success event means the probability of, sorry, I should be using a little p. Sorry for my handwriting. This is little p. Little p should be equals to the probability where
at most 18 cars will be traveling at a speed less than 60 kilometers per hour.
Wrong. You said at most 18 cars. Wrong. It shouldn't be at most 18. That's your final answer already. Py less than or equal 18 is your final answer already. It's a final conclusion. That's your final answer, the 0.995. No. This little p here, what I'm trying to establish here is there's a new random variable y representing number of cars traveling at a speed less than 80. It follows binomial distribution n, p. N being the 100. So I'll just change it to 100. And p being the value that is what I'm asking you now. What is p? Probability of what?
1 out of 10.
Yes, correct. It's 1 out of 10. The probability of any random car traveling at a speed less than 60. And then if you read the previous question, right over here. Understand? Does it make sense? I think that's what they did, I hope.
Yep.
Yeah, right? So it's just English translation. And you need to really memorize the 3 conditions required for binomial. You only have 2 distributions to deal with. Definitely, they will test you on these 2. So, yeah, that's all. Okay. You satisfy the 3 conditions. You got n fixed number of n trials which are all independent. You got a event here that is a success event, which is mutually exclusive with the failure event, where you do not have a random car traveling at a speed less than 60 km per hour. Not less than means more than equals 60, but that's not important. It's just a 1 minus of 1 over 10. Then the probability is fixed for the success event, and of course for the failure event, it's just 1 minus p, which is also fixed. Then from there, you can create your binomial distribution. Does that help?
Yeah.
Then from there, you know how to solve already. This one just use GC. We already go through binomial. It's just a setting up of this guy that you have problem with, right?
Yeah.
Okay, later I'll give you a homework to help. There's like 10 questions on this kind of what we call hidden binomial distribution, probability. How do I say this? Binomial within a binomial. Yeah, binomial within a binomial, or normal within a binomial. Okay, so this P requires you to think a little bit. Huh?
Okay.
Okay, moving on. That is question 6. I don't go through the rest, because you say you got the right answer.
Mm.
Okay, then question 7. What happened? Let me see. Can't remember. Something was wrong. Okay, you got the average, right? Yes, just take the average. You got the value of mu right. Just take the average of x less than 1, x more than 9. Correct. You understand this part. Then also given that 2 times of px less than 2 equal p of x less than 8. So what do you do here? Z less than 2 minus mu over sigma. Hold on. Wait a minute. How come you put a 6? What's this? Where do you get a 6 from?
This the sigma.
Oh my. Sigma, you write it like this, chicken egg, then you draw a horizontal line like that. Don't go and write it as a 6, please. No. Or the fancier way is like this. Like that. Fancy.
Okay.
That's what I usually do. But you don't need to be fancy. Just draw a circle, then draw a horizontal line like that. Make sure it's a horizontal line so that you distinguish it from a 6. It is not a 6. Oh my goodness. Okay. Yeah. Mu is like this. Sigma is like this. Or if you cannot, then just make it straight. And a U. Circle, horizontal line. You make sure it's longer. It looks like an M, right? You see, it looks like an M.
Yeah.
It's just a bit longer. That's why it's called M mu. It's a Greek version of M. Okay, whatever. Moving on. Not gonna save this. Okay. Handwriting you do with it. Okay. So. How? Oh, right. And also the mu is now a 5, right? So you can substitute in. That's fine. This is okay, assuming that this is a sigma. Yeah. Yes. Then your working is fine so far. But here you need to be careful. You need to do a special trick. What you need to realize is that when you have a normal distribution such that it is symmetrical about the 5. Okay, I'm just going to go back to the actual solution. I already drew some of the picture here. What you need to understand is that the mu, the standardized version should be what you're dealing with, right? And it follows a 0, 1 distribution. I mean, n01 distribution. In particular, there's the mu here, which is 0. That means that there's a line of symmetry here that's exactly the y-axis. Can you see that? X equal to 0 is the mu. Okay. Then in this case, you have what? 2 times. Okay, here we have this guy, and then you got stuck, right?
Yeah.
What you need to realize is that whenever you have unknowns on 2 different probabilities, that's going to be very problematic because we cannot take inverse norm when there are 2 separate probabilities. So here the special trick is to realize that these are both z, so it's symmetrical about the graph. So we look at the graph and interpret what does z less than -3 over sigma versus z less than positive 3 over sigma refer to. So look back at the graph now. Look at this graph. Maybe I make it a bit bigger. Okay, as much as I can. Then 3 over sigma, I hope you realize that it's positive divided by positive, so therefore it should be on the right of x equal to 0. Agree so far? The position of 3 over sigma?
Yeah.
Okay, then how about negative 3 over sigma? This fella here. Well, you should realize that it's just the negative version of this guy, right?
Yeah.
Oh, right. It's not a coincidence, it's by the design of the question. If not, you cannot solve the question already. It has to be negative so that there is a symmetry going on. So let's think about it. Why is z less than negative 3 over sigma? Let's remove the line first. Understand already? I heard a O. Okay, I don't know. Whatever.
I never say anything. Oh no.
Okay, whatever. Yeah, so z less than negative 3 over sigma, it just refers to this purple area. Is that okay?
Yeah.
Can How about z less than 3 over sigma? What does that mean? Can you try shading? Can you try drawing on this? Shade the area on this. What is P of z less than 3 over sigma referring to?
It's like the whole thing.
The whole thing, correct, exactly. Maybe I'll just draw it in a brown circle like this. Is that clear? Can?
Yeah.
So now they are telling you what they are doing is they rewrite it as 1 minus P of z less than negative 3 over sigma. That's very weird. It doesn't make sense. I thought, okay, I don't remove the symmetry first. I thought symmetry doesn't really mean anything until you see a graph. So it's just 1 minus P of z and 3 over sigma. I thought you should just flip the direction. Correct or not? Z less than 3 over sigma, by the rule that we follow, it's always 1 minus P of the same z, the same 3 over sigma, but you flip the direction.
Yeah.
Right? But how come it become less than negative 3 over sigma? What's going on? This guy, let's take a look. What is this? 1 minus P of z more than 3 over sigma. So now we pay our attention to z more than 3 over sigma. Light blue, can see? Where would that be? Can you shade for me this light blue area? P of z more than. Of course, the equal sign doesn't really matter. The right side, Correct. This region here. So I shade it in. Okay? Can Now I hope by symmetry you can tell. This purple area and this blue area are equal. Can you see or not?
Can.
Right? They are equal. Agree? Good. So now that means that we can translate this blue area. It is exactly equal to P of z less than negative 3 over sigma. That's the purple area. Is that clear? So by using the graph. So that means that we have 1 minus P of z less than negative 3 over sigma, which is what we have over here. Is that okay?
Yeah.
Because of symmetry about the x equal to 0. And the fact that these two values are the same. Why are we doing so much? Why we do so much just to convert it into z less than negative 3 over sigma? Because now we can do a special trick. You can think of this as essentially saying two I don't know what variable is not confusing. Let's pretend that we are solving a sec1 equation, sec1, when we learn algebra. 2x equals to 1 minus x. Can you solve for x?
Can I bring the x over?
Bring the x over, get 3x equal to 1, x equals to 1 over 3. That's exactly what we're doing here. The x here, the little x here, curvy x is referring to P of z less than negative 3 over sigma. Okay? Then after that, you get this guy x equals to 1/3. Is it clear so far? How you get 1/3?
Yeah.
You just have to replace this P of z less than negative 3 over sigma with a little x. Okay? Then you just solve for x. You get 1/3. Now, why do we do so much? Why do we do so much work? Because now we want to use inverse norm. Remember the format for inverse norm was what again? Inverse norm requires you to have P of some random variable, let's say x, less than some q, some number, equals to some area. Then you can use inverse norm. Now, finally, we have converted into that form. That's why now we did so much more. It's just so that we can satisfy that required format. Then we can use inverse norm to solve. Is that clear?
Yeah.
The problem here is at the beginning, the p's are separated. That's problematic because we cannot use inverse norm when there are two P values. You can only use inverse norm when it's this particular format, only one P. So that's why we have to force them to look exactly the same. Then you can bring over and have only one single P. Is that okay?
Yeah.
All right, very good. Then you use inverse norm. Do I need to show you this?
Don't need.
Don't need, then from there you solve for sigma. Okay, I'm sure you know how to do this. Let's move on to the next part. Now, they tell you 3 observations of X are taken. Determine the probability that 2 of them will be more than 7. So this is actually, again, a binomial distribution. Can you see that? 3 observations. That's a sample size n equal to 3.
Yeah.
Okay, let's just let y be the. Okay, let's figure out what this question is talking about first. The probability that 2 of them will be more than 7, and the others will be between 3 and 5. Actually, this might be a bit more complicated than a binomial. No, it's not exactly a binomial, sorry. Because these are 2 separate, they are not mutually exclusive events. They say 2 will be more than 7, others will be between 3 and 5. These are not mutually exclusive events. They're just independent events, no relationship to each other. Okay, so this is just a probability question. Sorry. No special binomial distribution for you here. Yeah, sorry. So it's either, let's highlight it, more than 7 versus between 3 and 5. So that means we want what? We want 2 of them to be blue color, blue and blue, and the others, we have a total of 3. 3 minus 2 gives you 1, so 1 yellow. Does it make sense?
Yeah.
You want to find the probability of blue, blue, then yellow. But wait, we are taking 3 observations, so that means the order actually matters, right? The 3 observations are distinct from each other, right? That means that you can arrange it. How many ways are there to arrange it? There's one way. Here's another way. The yellow move from the right to the middle, and here's a third way. The yellow move from the middle to the left, right, middle, left. 1, 2, 3 ways. Okay, but you should realize that the probability of each case, you're just going to multiply them, right? Probability of blue times probability of blue times probability of yellow, or blue times yellow times blue, or yellow times blue times blue. Then you add them together. You can do it manually, or the faster way is to realize the probabilities are all the same. You just take 3, choose 1. It's just 3 ways. You can manually list it out. It's just 3. Oh, this is just 3. Okay? Yeah, then this one, x1 more than 7, x2 more than 7, and x3 in between 3 and 5. Here, the 3 observations are independent from each other. That's why you must index them with x1, 2, and 3. Is that okay?
Yeah.
Can okay, good. Then you just have to key in the calculator. You realize that these events, you can just the x1, the x2, and the x3, they all follow the same distribution. So we can just sub into the. We found our mu, and we also found our mu using the average, and we found the sigma using our calculation. So we can just sub inside here, and we have the distribution for x. So we can definitely calculate what is p of x1 more than 7, x2 more than 7, as well as 3 less than equal x3 less than equal 5. Is this clear? How to calculate this?
Yeah.
Can then I move on?
Okay.
Okay, good. Okay. I haven't marked the rest. Let me see. Okay, so length of metal rods in a box are normally distributed with mean 1.3 and variance 0.7. Part 1, you want to find the greatest length L for which the probability that a randomly chosen metal rod is shorter than L is less than 0.3. So L be the length of randomly chosen metal rod. Okay, then L follows normal distribution 1.3, 0.7. Okay, good. Then you want capital L to be less than a length L, little L. Very good. Your handwriting is okay. Capital L for random variable, little L to represent the length. No, it really matters. It really matters. This one not a joke. This one not a joke. Very serious. If you go and write down L and then L like this, Like some people, their handwriting really cannot distinguish between capital and small letter. It's going to be very problematic. Okay, so good. Okay, little l, and then less than 0.3. Then after that, this luckily for us, this question is kind. They gave us the mu and sigma. We can just inverse norm. Actually, can we inverse norm? Cannot, not exactly. Because here there's a unknown L. So how do you get this value? I think you use GC, is it?
Yeah.
Yes, don't need to show. Okay, good. Then we got the L, little L. Then part 2, 8 metal rods are chosen at random. Determine the probability that at least 3 of them are longer than 1.4. So these 8 refers to sample size n equal 8. Right, makes sense? Quite easy. Then you definitely have a binomial distribution here because the probability of picking at least 3 longer than 1.4 is an event, the success event. At least 3 means what? Means that you have a new random variable more than or equals to 3. Then what's the event of the success event? It's this guy, longer than 1.4. So how do you describe it? Let me read your answer. You let x yeah, sorry, you use x okay, I follow. Yes, x, okay. Because just now we used capital L, we didn't use x yet. So you let x be number of rods out of 8 which are longer than 1.4. That's fine. Then x, that means x will follow binomial distribution. Sample size is 8, and then the probability of the success event is P of L more than 1.4. Exactly. Length of a randomly chosen metal rod is more than 1.4. Okay, longer than 1.4 is referring to of one random rod. Okay, just like the previous example just now, one random. What was that example? What was that question just now? Where was that question? I can't find the question. Okay, basically this is a longer than 1.4 is referring to only one rod, one random rod. Okay? Which is event L. More than 1.4. Okay, good. So now you have this as your binomial distribution. Then you want to find what? Probability that at least 3. So you just find P of x more than or equal to 3. Right? Just find P of x more than or equal to 3. Which is 1 minus P of x less than or equal to 2. Then you can just use a GC to calculate the less than or equal. By the way, here for binomial, you must rewrite it as 1 minus P of x less than or equals to something. Let's say you want to find P of x more than or equals to some k, it will be 1 minus P of x less than or equal to k minus 1. You have to rewrite it as less than or equal because the GC, even in your modern GC, it still cannot handle more than or equals. Okay, binom CDF. Did I spell it correctly? I don't know. Yeah, binomial CDF, you have to make sure it's less than or equal. Can? Very good. All right, part 2 is done. Part 3 there. Random sample of 100 metal rods. Random sample of 100. So definitely, I think n equal 100 binomial already. Right from the first 5 words, I can tell it must be binomial. I predict maybe I might be wrong, but let's just have that in mind. Selected. Find the expected number of metal rods with lengths that are between 1.2 and 1.6. Okay, so what is the event that we're interested in? It must be something that's like 1.2 less than x less than 1.6. Right? Then you want to find the expected number with lengths that are 1.2 to 1.6. So maybe this shouldn't be x anymore. This should be length, right? So shouldn't it be L, which we already defined here? Make sense? Just from reading lengths between 1.2 1.6. So L is length. So just put it in between. Then we want to find the expected number. What would that be? This guy, inequality, right? Definitely must always tag along with what in front?
The B.
No.
Oh, P.
P, probability, right? Probability. Okay. So now if you have probability that's in between 1.2 and 1.6, and you know that that is your what do you call it? The event of interest, right?
Yeah.
Or the full event. Then, and we also identified just now the n equals to 100 here, right? N equals 100. So that means that we now need to have a we want to find the expected number, right? That means that we need to come up with a new random variable y that's following a binomial distribution. Sample size is 100. The probability p, what do you think it is? It must be a probability of the event of interest. What is the event of interest? The yellow one. One random metal rod, the length is in between 1.2 and 1.6. One random metal rod, length between 1.2 and 1.6. Isn't that just p of 1.2 less than L less than 1.6?
Yeah.
Exactly. So that means we can replace this with the p of 1.2 less than L less than 1. No space. Less than 1.6. Okay, that is your probability. Then, but what's y? What's y? You want expected number of da, 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 da. What do you think is y? Okay, let's focus on the word expected first. Expected just means find the expectation. Find the expectation. Dot. Expectation of dot is just to put in as a placeholder. It has to be a random variable, right? What do you think is the random variable?
The expected variable?
No. Expected just means you want to find the expectation of a certain random variable. What do you think is the random variable? I already wrote it here. It's y.
Oh.
Right or not? So the question is actually asking you find the expectation of y. Right?
Yeah.
Without knowing what's y, you should know it's asking you to find expectation of y. But what is y? Just read the question. Find the expected. Continue.
Number of metal rods.
With lengths that are between. That's it. That's the y. Y is the number of metal rods with lengths that are between 1.2 and 1.6 meters.
Oh.
That's it. Was that too simple a question? That's why I'm confused. Okay, sorry.
Yeah, didn't know.
Yeah, y is the number of then it follows binomial distribution. How many? Oh wait, sorry. Actually, sorry. No. Oh my goodness. Let me think a bit. I might be wrong here. It's not the number of. Y should be the number of samples. Is it not? Actually, let's just look at the solution. Is it number of? I think I'm confusing myself. Yeah, sorry, it's just a number of. Yeah, I was right the first time. Okay, good. So how do you find the, what do you call it? The expectation of a binomial random variable y, where y is, I should define y is number of metal. How do you find expectation? What's the formula? Remember? For binomial expectation?
N times P.
Very good. Yes, must memorize. It is not the proof is not in the syllabus. You need to memorize. Likewise, for variance, you also need to memorize what is variance of y.
Is it N1 minus P?
It's 1 minus P, exactly. NPQ. I like to remember it as NPQ. Q stands for 1 minus P. Just keep on reciting this until you can memorize. NP 1 minus P, NP for expectation. Just think of it as like, if like for example, probability is like on average how many y's you have, right? Then if you multiply that by n, that just gives you the. Okay, how do I phrase this? Let me think of a good example. Okay, you can think of it like this. When you are flipping, sorry, not flipping, you're rolling a die, right? Singular is die. There are 6 possibilities. Then there's a probability for each one. It's 1, 6, 1, 6, 1, 6, right?
Yeah.
Then what's the probability here? The letter P of x equals to, let's say you're rolling a 2. It's just 1 over 6.
Yeah.
Then in this case, if you multiply it by that correct? Is that a correct explanation? Okay, sorry. Let me remove this. No, that was a bad example. I think I'm gonna confuse you if I explain this. I think I'll just leave it as NP. It's just a standard formula to find out. Probability is on every the chance of you getting one particular event. Then if you multiply by n, you'll scale it up to all of the possible events. Then that will give you the average number. Does that make sense?
Yeah.
Roughly huh? Okay, but anyways, how do you apply it over here? N is what? In this Y. N is
100.
Then what is P?
The 1/10.
Huh?
No,
not 1/10. That was a previous question already.
Whoops.
What's this? P. Is it my handwriting?
But
This guy, lor. The probability
I
of
thought
finding.
it's not known.
Huh? What's not known?
The probability that is between 1.2.
Yes, then that's why you need to calculate it, lor. We have L already, Normal distribution 1.3, 0.7. You can just use normal CDF. Just use normal CDF. Yes. Of course, it's not so easy. Must do some calculation on your own.
Okay.
But we can calculate it on our own, right? That's the most important thing. Right? Yeah. It's just a simple keying in of the GC. Just a simple step. Okay. But knowing that you need to key this thing in the GC, that's the important step. That's what I'm asking you. What is the probability? This guy. Probability of L in between 1.2, 1.6. Okay, so let me just finish up writing this sentence. Number of metal rods with length between 1.2 meters, 1.6 meters. Okay, you can fill in the prepositions and the articles and whatever. Spell it out in full. Okay, on your own. Yeah, then just have to, so let's just look at the solution. It's very simple. You just need to multiply n 100 times p. Just use GC. That's all. Okay, NP. It's an NP. It's a binomial distribution. That's why you can use the formula NP.
Okay, I didn't know can times the unknown.
It's not an unknown, it's a number.
Yeah, but I didn't know need to find.
Yeah, you have to read the question. Okay, every time you see 100 samples, you must think binomial distribution. Then you should start writing out a new random variable, and then it follows binomial. Sorry, my tilde not nice. Then you fill in the blank n and p. What is n? What is p? Then that's when you have to start thinking, what is the successful event, the success and failure event? That will guide you towards finding out this p. What is the successful event? In this case, you just read the question. Expected number of metal rods. Number of metal rods with length that are between 1.2 and 1.6. So length that are between 1.2 and 1.6 is the success event. Then n will be the number of samples, 100. Then you have to be a bit more careful. This question is tricky. They didn't ask for probability. They asked for expected number. So you just take the expectation of y. Then you take NP. How about the variance? Find the variance in the number of metal rods that have length between 1.2 and 1.6.
Is
that's just
n 1 minus p.
Just n times p. Sorry, what do you say?
The n times 1 minus p.
Not enough. Still need times a p. N times p times 1 minus p. Okay. I like to remember it as NPQ. NPQ. It sounds like ambiguity. NPQ. I don't know if it helps you. Variance, right? Variance is like varying. It's a very ambiguous. NPQ. Then I can remember NPQ. Okay, that's very lame. Sorry, just memorize it. Okay, Ken, that's done. Moving on. Question 9, part 1. I haven't read yet. Sorry. Manager claims that the time spent by each customer at his supermarket follows normal distribution, mean 35 minutes, standard deviation 30 minutes. Satisfaction made a comment. Distribution doesn't provide adequate model. Do you agree? Give a reason. Maybe it's not independent. No. It's always that's the standard assumption. Make sure that you know this phrase, IID. Do you know what's IID?
No.
It means independent and identically distributed. This one, wow, you take statistics class, you don't know this phrase. Oh no, oh no. Very
No.
This means that the random variables, like let's say in this case, x follows, I just use the letter x, 35, 30 square. It means that the x are independent as well as they are the same distribution for each sample you take. So x1, x2, x3, they are all follow the same sample. x1, x2, all the way to x35. Hey, no, x, how many samples? Hey, they didn't provide a sample size. Okay, I'll just xn. All these, they follow the same distribution, n 35, 30 square. And they are independent, means that probability you can just multiply. You you know what's independent, right? P of A given B equals to P of A, or P of A intersect B is equals to P of A times P of B, right? So that means that if you want, let's say you collect two particular samples, they each follow a random variable that is the same, normal 35, 30 square. Then you want the first sample to be I don't know, more than 2. Then the other guy is more than 7. If you need both of these cases at the same time, you can just multiply their probabilities. Okay, yeah, don't need to think so hard because it is independent. Just multiply. Just like the previous question 8, when we, is it question 8? No, it's question 7 here. You can just multiply these probabilities, right? Because there's a hidden assumption that they are independent. Sorry, this question not so perfect because they never assume this, but by default, we assume IID, independent and identically distributed random variables. So the x1 here, the x2 here, and the x3 here, they are independent and identically distributed. Identically distributed means they follow the same formula here, n mu comma sigma square. So we can just use our same mu and same sigma when we are typing in the normal CDF. Then the independence assumption allows us to just multiply probability. No need to do any conditional probability or anything. Not so complicated. Just multiply. Okay, sure. Maybe I should write this down. X1, X2, X3 are IID, meaning independent and identically distributed. Identical distribution means same distributed. Identically distributed means, i.e., follows same. Xi follows n. What was the distribution? 5, 6.96 square. For I equals 1, 2, 3. Okay, and independent here just means can multiply probability. No condition. Basically, P of A intersect B. Like two events that you want to overlap, like happen simultaneously at the same time, you can just multiply their probabilities, individual probabilities together. Like you want the first sample to have more than 7. You want the second sample, not sample, what do you call this? Random variable, observations. Sorry, it should be observation, not sample. Oh my goodness. Yeah, observation. You want the first observation to be more than 7, second one more than 7, third one in between 3 and 5. You want these 3 events at the same time, so intersect. But because they are independent, you can just multiply. Okay, just multiply.
Okay.
All right. Yeah, that's a hidden assumption in all of the normal distribution questions. IID, independent and identically distributed. That's how you can solve this question. If not, if you don't have this assumption, you actually cannot solve this. If they follow different distributions, wow, that's going to be very difficult. Okay? Not independent, even worse. Cannot just multiply, need to do conditional probability. Very, very challenging. Okay? Can I? Okay. Hidden assumption. Clear. Good. Next. What? Yeah. Maybe that's one of the assumptions. Do you agree? I agree. I give a reason. Maybe they are not independent. maybe one customer, he spends a long time time spent by each customer at his supermarket. Yeah, maybe a customer spends a long time at the supermarket because he is having trouble finding his money in his wallet or something. Then he hold up the queue. So the amount of time spent by the other person just behind him in the queue will also be equivalently longer. So they are dependent. Make sense?
Yeah.
Right? Yeah, so that's why it's not independent. That's why this may not be true. Let's just look at their solution. Oh wait, you mentioned standard deviation too close to the mean. Oh, I never thought about that. Would that be troublesome? I'm not so sure. Let's just read their solution.
Yeah.
Okay, let x denote the time spent by the customer in the supermarket. So blah. Then x less than 0 happens to be 0.122. Wow, this one even clearer. How can you spend negative amount of time? Time traveling backwards? No, nonsense. This one. So this has a positive probability that the time spent is less than 0, meaning time spent x is negative, which is impossible. It should be a 0. So that means the model is not very accurate. Significantly big. That shouldn't be the case. That should be 0. You cannot spend negative time. Or you will spend some time as long as you're inside the market. Or at most, or maybe at least 0 seconds. However, x is a non-negative quantity, therefore normal distribution will not provide an adequate model. Okay, can. Yeah, that actually is a stronger reason. How about part 2? Is your part 2 okay? Do you mark? Oh, haven't tried. Oh, couldn't get answer. Oh, you got it.
Yeah.
Correct. Actually, this is a very important question. This is a very important question. Very standard. Will always come out. They will mention something like two randomly chosen, so that it will be they are totally random, right? So they have no relationship with each other. So you need to put x1 to and x2 to represent the time spent by customer number 1 and customer number 2. These two random guys, and then you have afterwards they say more than 3 times that of another randomly chosen customer. Here, make sure you understand the phrasing 3 times that. It means you need 3 times, literally 3 times here, multiplied by x3. Is it clear? 3 times of the time spent, x represent time spent by customer number 3. They must have index 1, 2, and 3. Is that okay?
Yeah.
You managed to set this up, means you understand this all. Okay, good. Then just bring it over, and then after that you calculate the expectation and variance. I haven't really went through with you. Do you need me to go through calculating expectation and variance of the new random variable here?
I think it's okay.
Should be okay, huh? Yeah. It is almost the same as the binomial, and yeah. So should be fine, I guess. I'll go through if you got a wrong question then. How about question 10? Question 10, what happened? Is it right or wrong? Have you marked it?
No way.
Right. Okay, I see the answer is correct. Then I'm going to skip already. Okay, good. Can. Next. Question 11. Oh, what happened? Factory produces a particular brand of oil in bottles of 3 sizes, namely small, regular, and large. Amount of oil in each type of bottle in milliliters is assumed to be normally distributed as shown in the table below. They give you the mean and the variance. So variance, not standard deviation. Explain why the amount of oil in a small bottle can be modeled by a normal distribution, even though amount of oil cannot possibly be negative. Just now the argument was negative. That's why it's a bad model. Now they're telling you, even though it's negative, it's okay. Why? I'm not too sure. Explain why. I guess for values that are. Let me think a bit. What is the random variable we're looking at here? Amount of oil. Okay, I'm not too sure. Let's just look at the solution. What did they say? Okay, let's just read that solution. Let S, R, and L be the amount of oil contained in a randomly chosen small, regular, or large bottle, respectively. So they let a different random variable represent each bottle's amount. Cannot just let a single random variable represent the amount. Must be 3 distinct random variables. Method 1, what did they say? Since a normal random variable takes on all the real numbers, and here P of S less than 0 is approximately 0. Okay, this one you can calculate with a GC. Let's just calculate it on a GC. What is that P of S less than 0? Okay, second distribution. Small is following normal distribution, right? Then in this case, actually, did they mention normal? Yeah, they mentioned normal. Okay, good. So the mean is 610, and sorry, we need S less than 0, so we should have an upper bound being 0 and the lower bound being negative. Then the mean is 610, and the variance is what? Variance is just square root. Oh, sorry, variance is the sigma square. So we need the standard deviation square. So to find the standard deviation, we take the square root of 25. Okay, we get 0. Okay, lor. So it's possible that it's possible for us to have this distribution because the probability will be almost 0 for it to be negative. So it's a good model. Does it make sense?
Kind of.
Yeah, basically the graph of the small will look something like this. Okay, it shouldn't be over, it shouldn't intersect, but I guess I should try to make it a bit more accurate. Never intersect, just very, 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 very close to 0, almost horizontal already. And here is x equals to 610. So they're telling you that if x is less than 0, if the S representing amount of oil is negative, find the probability. Here, this model, if you calculate using our GC, we got a 0. A 0, which is very, very small. It's actually probably a it cannot be 0. It has to be a positive probability, but it is so small that the GC was the GC decided to round it off to 0. Okay, or the GC couldn't calculate it to enough accuracy, and they just gave us a 0 as the answer, right? A 0 as the answer.
Yeah.
Okay, so that's why, because it's 0, even though S is P of S less than 0 is a possible scenario in this model where S follows normal distribution, the probability results in 0, which means that we can essentially ignore this case. It won't happen. So that means that this model is good. It's still good enough. Okay, that's what they are trying to say here. Does it make sense? You won't, even though this normal distribution accounts for negative values of S or negative volume, but it's okay. The probability is 0. So we will not be affected in our probability calculations. Is that okay? Is that okay? I cannot hear you.
Sorry?
Mic test, is this okay?
Hello. Yeah, can.
Okay, good. Can. All right, then method 2. I couldn't hear you. I'm not sure why. Yeah, so method 2, let's read this. Negative values of the amount of oil in a small bottle would be more than 3 standard deviations away from the mean, making probability of negative values of the amount of oil negligible. As we know that P of x minus 360 less than 3 times 5 is 99.7%. Okay, this one is they are just telling again, they're telling you that this values of S being very negative is many distances away from the mean 610. How many, and then the units that they represent by saying in terms of distance is standard deviation. Okay, so you can think of the amount of data, what do you call this? proportion of data to be in terms of the distance away from the mean, in terms of number of standard deviations away.
Oh.
Does it make sense?
Oh.
So basically,
Um.
they're trying to tell you that negative values are far, far away from the mean, which means that you have a small probability of seeing them, which is very good because we want to make sure that the probability of getting a negative value for the S to be small. Okay.
Oh, okay.
Yeah. I think method one would be easier to explain.
Yeah.
Basically, probability of getting negative value of S is small. I think that's good enough.
So because it's small, then it can be included.
Not included. I mean, it means the model is good. I guess so lah. Yeah, it can be included. The purpose of having to include this is so that we can get a smooth curve. Okay, if we suddenly chop off at here, then we won't be able to get our probability under the entire curve to sum up to 1. Okay, then that's the requirement for area under a curve must be equal to 1. Probability must add up to 1. So we're just including this so that we can get a smooth curve. But that's beyond the question already. That's not what they're asking. They're not asking whether it should be included or not. They're asking, is the model good or not? It's good. Just answer it's good. It's small, therefore, even though we can consider negative, which is a possible counter argument for why it's a bad model, we will say that it is still okay because it's negative. Because the negative values of S is small. Okay, that's all. That's all. Don't need to elaborate more. Can we move on?
Can.
Yeah, this one you go discuss some more, it become philosophy lesson already. No. Part 2, we're trying to do math or calculation only. Now, 3 small bottles are randomly chosen. Find the probability that one of the small bottles contains more than 615 ml of oil, while the other 2 small bottles contain less than 602 ml of oil. Okay, just like this. S more than 615, S less than 602. But then you have 2 bottles, right? So you just have to square it. And then we have to consider all the ways that we can draw it, which is 3 choose 2, or 3 factorial over 2 factorial. This is the same as 3 choose 2, which is the same as 3. Similar to the question before. Remember this one? This guy, similar to this question.
Yeah.
Right, it was question 7. So you also need to calculate the probability over here. Can now part 2?
Can.
How about part 3? Let's see. Find the value of sigma such that 80% of regular bottles contain between 1040 and 1060 ml of oil. So yeah, this one is a standard question. You just need to know that for regular, it follows normal distribution, mean 1050, variance sigma square. My sigma, sometimes my downwards arrow goes a bit down. I hope you are not confusing it with an A. Okay, I just draw a circle and a horizontal line like that. Okay, then they are telling you find the value of oil such that the 80%. 80% here, when you see percentage or you see like 1 out of 20 a red, that kind of thing, it's really referring to probability 0.8. Also, P of whatever equals 0.8. Is this part clear to you?
Yeah.
Then what's the event that's happening that gives you 80%? They say that the volume is what? Between 1040 and 1060. So just put down 1040 less than something, less than 1060. What's the letter in between? Which bottle are we looking at? Regular. So it must be R. Is that okay?
Yeah.
Okay, then just how do you calculate this? How do you calculate sigma from here? Can we inverse norm straight away?
Cannot.
Is it in a desired format? It's not in the correct format, right? What's the problem here? This guy, the 1040. So what should we do?
The 1040.
Right? Because if you want to find inverse norm, what What's the standard format? P of x less than q equals to some number. Here we only want x less than q, a random variable followed by a number on the right side. Random variable followed by a number on the right side, that's why it's okay. So who's the odd one out? That fella over there, the 1040. That's what I'm talking about, the odd one out. It doesn't follow our required format in order to use inverse norm. So we should try to be creative here. Here, I hope you notice that there's a 1050 here, then there's 1040 and 1060. What pattern do you notice?
It's plus 10.
Plus 10, plus 10. So it's symmetrical, right?
Yeah.
Doesn't it remind you of the previous question that you did? Okay, I'm gonna copy this down to the bottom. Yeah, this is what they did. Here, okay, you can draw a graph. This would represent the mean, x equals 1050 to represent a vertical line. That's mean equals 1050. Then the data, then what we are trying to find here, we're trying to find from 1040 all the way to 1060. Yeah, my graph not nice. Let me try and modify this so it looks nice. Okay, then we're trying to find the area underneath the curve in between 1040 and 1060. So it's referring to this area here. Can you see?
Yeah.
And you know this is 0.8. But because of symmetry, you know that you can split half, right? Half. Yes?
Yeah.
So how can you translate this problem, given that you know this graph, into something that's of the format P of a random variable, let's just say R, less than some number equals to a number. Your goal is to find out what is those two question marks. Translate this into something like this. How? What should you do with these two blank spaces?
Add together
Okay. What do you get if you add them together?
is 0.2.
Okay, good. So, but because of symmetry here and here should also be 0.2 divided by
2.
Yeah, okay, good. So let's just make it look nice. So 0.2 over 2, which is 0.1. Likewise, over here also 0.1. Then how? You need this format. R less than something equals to a certain area. This will be one of those x coordinates. So it's either 1040, 1050, or 1060. Choose one.
1040.
Sure. Then what is this equal to? Area underneath the curve from 1040 all the way to the left. What's that equal to?
0.1.
Exactly. And can you inverse norm now?
No, can.
Cannot. Not yet. Still got one more thing to do.
The variance is unknown.
So we need to
standardize.
Exactly. So 1040 minus away mean 1050 divide by the sigma, then equals to 0.1. Then we can inverse norm. So we get 1040 minus 1050 over sigma is equals to inverse norm. Let's just do it on a calculator. Shift, distribute, inverse norm, enter. What happened? Okay. Then just key in the area. Right hand side 0.1. Mu and sigma can fill in 0.1 standard because it's a standard normal distribution. Enter and you obtain negative 1.281. 5. Okay, then after that, just solve for sigma. Is that okay?
Okay.
Yeah, so it's 1040 minus 1050 is negative 10. Negative 10 divided by negative of the answer from before. Negative 10 divided by answer. So you get this as your answer for sigma. Is that okay?
Yeah.
Okay, this is one way to do it. The solution gave a slightly different way. What they did is they standardized straight away. Okay, here they standardized straight away. Minus 1050 over sigma, minus 1050 over sigma equals 0.1. Then from here, because you need to use inverse norm, so they change the direction. More than becomes less than. How did they do that? To get those, and they also change from 0.1 to 0.9. What they did was, maybe first we simplify this down into just a 10 over sigma. Huh? So P of Z more than 10 over sigma equals 0.1. You want to change the direction, you should always rewrite it as 1 minus Z less than 10 over sigma equals 0.1. Okay, then from there, you make this fella the subject. 1 minus X equals 0.1, therefore X must be equals 0.9, what we have over here. Is that okay?
Yeah.
Okay, then now that you have less than, you can just use in a standard form, you can just use what do you call that thing? Inverse norm. Or you can also work with this guy, inverse norm. So they gave like so they actually gave two extra methods in addition to my method here. Okay, my method uses a graph, their method uses standardization and inverse norm, which is really just roughly the same thing. So 3 different methods, and you can solve for sigma. Okay?
Okay.
Okay, very good. And then how about part 4? Let's see. I can't see. Your part 4 was okay? Is it?
Yeah,
you got the right answer.
Yeah, I did part 4.
Yeah, okay, this is fine. L1 plus L2, then more than 4S. Oh, you did have a L1 and L2, large 1 and large 2. Can. Just find expectation and variance. And then you get the new distribution. Correct, you call it letter D, capital D, that's fine. Then D more than 0. Yeah, because you already modified it over here. Can. Then you just key in the GC and you get using the normal CDF and you get the answer. Can. Good. Moving on. Question 12, what happened? Let's read the question. Manufacturing process produces pencils with diameter normally distributed with mean 0.9 cm and pencil sharpeners with holes to fit the pencils with diameters normally distributed with mean 0.91 cm. Let me think a bit. Mean 0.9 pencil sharpener. Okay, can. This process allows the manufacturers to adjust the standard deviations of the diameter for both the pencils and the sharpener holes. Part 1. If the standard deviation of both pencils and sharpener holes are adjusted to 0.005 cm, find the probability that a randomly chosen pencil will not be able to fit into a randomly chosen sharpener. That just means that the diameter is bigger. Diameter of the pencil is bigger than diameter of the pencil sharpener hole. Make sense? Okay, good. So you probably need 2 random variables here. Okay, so you use a random variable capital P for pencils diameter, and you use what is this? What is this? P11?
Be denoted P.
What's that?
PH.
Oh.
Hole.
Oh, okay. Hey. Wow. When you are trying to write that out, please use subscript notation like this. Make it obvious that it's a subscript. Okay? To distinguish from P. If not, it's very confusing. And yeah, it's not such a good idea to use subscript notation. Just use a totally different letter. Maybe just use H. Easier. Or if not, you may get confused. Okay, so or you use double letter, no subscript notation. Oh, that's not so good. Not so good. Try to use only single letter to represent random variable so that it is less confusing. You don't accidentally end up thinking it's P times H. Wow, troublesome. Or pH level in chemistry, even more troublesome. Okay, let's just see what do you write down. 0.9 here, and then the standard deviation is this guy. How did you get 0.005? Oh, right, they already gave it here. Can. And standard deviation. So for the presentation, you need a variance. So that means it's standard deviation square for both of them. And it's 0.9 and 0.91 given by the question here and there. Okay, then for part 1, you want it to not be able to fit. So that means that you need the pH minus P to be negative. Does it make sense? Let me think out. Yeah, correct. Yes, correct. Then now you need to calculate the expectation of this random variable. So it's just this guy minus that guy. So 0.91 minus 0.9 is 0.01. That's fine. Variance, variance will be okay, this one let me think a bit. Variance will be 0.005 square for the pH. Oh, sorry, maybe I should write this down. Variance of pH minus, sorry, when you have minus, you should plus a -1 square times the variance of P, right? So it just becomes 2 times of it because the variance happens to be the same. So then you get 2 times of this 0.005 square. Let me double check your answer. You get 0.00005. That is correct. Then after that, that means that the pH minus P, it follows a normal distribution. Mean is the E that you calculated, 0.01. The variance is 0.0005. Okay, then from here you can calculate the probability it's less than 0. You got 0. Why? Let me double check. Is it actually 0? I don't know. Or was there something wrong with the calculation? Let's see.
P, like, I got 0.
Let me just double check. I'm not sure. The mean in this case is what? 0.01. Then the standard deviation here, what is it? Square root, right? You need to take a square root of the variance.
Yeah.
It will be strongly recommended to write this down so that you are clearer on what to type in the GC. Don't just find expectation and variance. Give the conclusion here. Also, it's less confusing. Then after that, you can paste it. Not 0. Not 0. I suspect you forgot to square root, is it? Let's check. If you didn't actually square root it, what happens? I suspect you didn't square root it. Oh, bracket. There you go. I think you didn't square root. Just now, previous question in a part G or something, you also forgot to square root. Must remember to square root, okay? Yeah. Please square root in GC. When you type in the GC, you must square root. Okay, so you get 0.078649, which is basically the answer here. Okay? Okay, so your working is fine. Just the last step, keying into GC. Don't waste that 1 mark. You got all the working fine. You just need to type in correctly, take the square root. Okay, then part 2, state an assumption needed for your calculations in part 1. Independence. Independence, it's always IID, independence and identically distributed. Okay, of the 2 variables. Okay, actually they already gave you normally, so that means it's an assumption already made. Let me just see their solution. What did they ask you? Part 2, diameters of the pencil and sharpener's hole are independent of each other. Okay, good. Yes. Then the part 3 you didn't circle. Is it okay?
I think I didn't do it.
Oh, didn't do part 3. Wait.
I think
Yeah, you didn't do. Okay.
missed it out. Yeah.
Okay. Let's see. So pencils with diameters that differ from its mean by more than 0.02 cm are considered as substandard. Find the standard deviation that should be set for the pencil's diameter so that the manufacturer can keep the percentage of substandard pencils to be 2.2%. Okay, so what it means is that we want to make the standard deviation an unknown, sigma, and then we try to solve for sigma given this condition. Percentage of substandard 2.2%. Here you need to understand the keyword here, differ. Differ here means minus, means plus, but not just one direction, both directions. So that means that we actually need to use absolute value. Okay, when you hear the word differ, think of absolute value of the difference. So take absolute value first of the difference between your what, pH and the P. Okay, and you want it to be, what is it? Substand. Wait, let me read the question again. Blah blah blah. So that the manufacturer can keep the percentage of substandard pencils to be 2.2%. Okay, so they want the substandard to be 2.2%. They want substandard, so that means we want this to be more than 0.02. Probability, right? They gave percentage, so it's probability equals 2, I think 0.022, right? 2.2% just divide by 100 to the 2.2 and you get 0.022. Yes?
Yeah.
Okay, good. So now we can calculate this guy. How do we calculate that guy? Let's see. We need P of pH minus P. The direction doesn't matter anymore because absolute value. Must remember, difference means you must take absolute value. Okay, good. So now we can evaluate this guy. I hope you remember that absolute value of x minus a less than, let's say 3. Okay, I just put a concrete number, let's say 7. It means that, more than, to follow the same format. It will be x minus 7 less than negative 3 or x minus 7 more than positive 3. Then after that, you can simplify, bring the minus 7 over. So here's what we're going to do, exactly the same. We're going to split it up as pH minus P less than negative 0.022. Did I miss out 2? Yeah. Oh, sorry. No. Sorry. The difference should be more than 0.02. So it's just 0.02 here. Wow, they're trying to trick you. They put so many 2s here. Just be careful. Or pH minus P to be more than positive 0.02 equals 0.022. So now when you have an OR, there are 2 separate cases. It means you can split up into 2 probabilities, but you erase the or just plus them together. Is that okay?
Yeah.
Okay, so how do we calculate these 2 guys? Just we got a distribution already, right? Over here. Right, so that's why it's very important to write the distribution so that in the future part 3 we can use it. Don't just write it like that. This one not the perfect presentation. You write it like this: P tilde n, give me the mean, give me the variance. Then you will know what to do subsequently. Do I need to go through the rest? Actually, I think maybe I need to because here, sorry, I forgot. I already mentioned it just now. I wanted the sigma to remain as a variable here in part 3. Sigma must remain as a sigma. So that means that this is no longer just 0.01, 0.00005. It becomes, this guy follows just an unknown sigma square. For the variance, sigma square variance, then sigma is standard deviation. Is that okay?
Yeah.
Okay, then from there, we need to calculate what is this expression. We can't really calculate because there's an unknown. So what should we do?
Standardized.
Yes, correct. So standardize here, that means we'll end up with P. I'll just calculate it. Sorry, this question not as easy as it seems. Minus away the mean, then divide by a sigma. Plus this guy, same thing. P of, I forgot to put a P here. P of Z more than 0.02 minus 0.01 divided by sigma equals to the right hand side constant 0.022. Can?
Can.
Okay, good. How to continue? Problem again. You want to take inverse norm, but you have 2 P's. What do you have to do? Maybe we need to simplify a bit more first before we continue. Simplify a bit more. This guy is actually negative 0.03 over sigma. That guy is Z less than, or Z more than 0.01 over sigma. How to continue? Just keep in mind the probability distribution of the pH minus P.
draw the PDF.
Yes. In this case, where is my center? It's a PDF of what variable?
0.01 Z.
No. Z. No. So it's not 0.01 anymore. Z is what? And forget.
0.1.
0.1. So what's the mean? The mean will be your line of symmetry.
0.
Yes, correct. Also, let me just draw a broken dotted line. X equal to 0 is your mean. And what do we want? We want it to be less than negative 0.03 over sigma. So maybe somewhere here. We want it to be more than 0.01 sigma. Unfortunately, here it is not symmetrical, right? 0.01 versus 0.03.
Yeah.
Then how? Oh no. This I hope you understand that the area that I'm talking about, this blue part is this region here. Then this purple part is this region here. They want it added together to give you 0.022.
Yeah, but it's not symmetrical.
Correct. Then how?
So,
Remember, we want what's our final goal? What's our final goal? Our final goal is to solve for sigma. How do we solve for sigma? What function do we need to use in the GC?
the inverse norm.
Very good. So write this down, your thought process. To solve for sigma, use first step was to do standardization. And honestly, the purpose of standardization is so that we can do step 2, use GC's inverse norm. Okay, that's our weapon, the strongest weapon, the only weapon that can help us to solve this question, inverse norm. And unfortunately, GC is very straightforward. It cannot adapt. So you must adapt to the GC. The GC cannot adapt to you. You need to adapt to the GC. And the requirement for using the powerful weapon, the inverse norm, is that you must have this format. What is the format again? Can we recall? P of some random variable x, more or less than?
Less than.
Less than some number, let's say, for example, 55 or 5, okay? Then right hand side is it less than, or is it equal, or is it more than?
It's equal.
Equal. Okay, the color a bit not nice. Let me change it. Just use red, Must be equal to what else on the right hand side? Can it be a variable, sigma?
Cannot, it must be like a number.
A number, yes, correct. Okay, of course, probability cannot be more than 1, so 0.2, for example. Okay, so that's our goal. Random variable less than number equals number. Now, do we have that? Don't have. How can we force it? Can we have a short 5-minute break? I need to.
Yeah, sure.
Then you think about it. How do you convert this into a standard format? Of course, it should be P of Z less than question mark equals question mark. So think about what that question mark is. Then we'll have a short break. I'll come back and review the answer.
Okay.
Yeah. Okay, be back. Mic test, mic test.
Hello.
Hello. Hi, I'm back. Sorry for the delay.
It's okay.
So have you figured out what's the two question marks?
Negative 0.01 over sigma.
How did you get negative 0.01? The
Negative
first one. Maybe.
negative 0.03 sigma plus 0.01 sigma over 2.
Over 2. Okay, not correct. I tried my best to make it not symmetrical already. Because if you take the middle ground, you end up here. Then okay, let's say you have that. Then what's on the right hand side? What do you have on the right hand side? 0.5?
Yeah.
I tried my best to make it not symmetrical. Definitely not 0.5. Because when do you have 0.5? Only when it's z less than 0. Z less than 0, then you get 0.5. That's the symmetry line of symmetry. Right? Do you get that? P of z less than 0 is 0.5. If you take the average, the negative, you see it's negative divided by positive, so it's a negative value. So that means it's the line over here. X equal negative 0.01 over sigma. Then if you find the left tail area, definitely not 0.5, right? Smaller than 0.5. So that means it's wrong. What should you do instead? Have to be a bit more creative. What you need to realize is that here is blue, here is purple. Blue plus purple gives you 0.022. Agree? Yes?
Yeah.
Then what about green? This part here. What do you think is the area of green?
1 minus the 0.03 over sigma.
No, area. That one is the x. These are the x coordinates. We don't want x coordinate. Area.
1 minus 0.022.
Correct. Because 0.022 is referring to blue area and purple area added together. 1 here is referring to total area. So total minus away sum of blue and purple, which is 0.022, you'll end up with 0.978. That is your green area. Is that okay? Then now we want z less than some x coordinate such that it's equal to a certain area, left tail area. Left tail area is actually hidden. There's a hidden negative infinity less than. So you must start all the way from negative infinity, and then you shade in all the way. So how? Actually, does it help? Hold on a second. Let me see. Oh wait, we also don't know the blue area. Then how? Let me think a bit. Did I do something wrongly? Don't think so. I recycled the distribution here. Is it correct or not? Let me see the question again. Sorry. No. Should be the same. Okay. Let's just look at the solution. Let's see what they have. Hey, negative 0.2 and positive 0.02. 0.9. Right. We set up the question a bit too complicated. To be a bit too complicated. Oh, sorry, I read the question wrongly. Let's read the question again now. Pencils with diameters that differ from its mean by more than 0.02 are considered substandard. Did they mention the pencil sharpener?
No.
No. Then find the standard deviation that should be set for the pencils diameter so that the manufacturer can keep the percentage of substandard pencils to be 2.2%. Did they mention pencil sharpener at all? No. So pencil whole pH, is it relevant here?
No.
Yeah, sorry, I didn't read that. Oh my goodness. The question is a lot simpler.
Oh.
Sorry. Pencil hole here, pencil sharpener hole is not relevant at all. We are comparing the pencil's diameter from its mean, where the mean is a constant. Let's look at the carefully. Pencil diameter is mean 0.9. Oh my goodness. So this should have been a 0.9. Okay. Not pH, it's 0.9. We're comparing with not the diameter, but with the pencil's mean diameter. Yeah, versus the variable diameter. Okay, yes. Oh, okay. Sorry. I didn't think of that. I didn't see carefully. Okay, now you're gonna change everything. Okay, pH everywhere. Gonna change into just the 0.9. Yeah, and then of course the distribution we're gonna be using will also be involving a 0.9. So okay, so this is not relevant anymore. Change the pH to 0.9. Actually, know what? No, we don't even need this. We can simplify the following. Let's just simplify. We might not even, okay, do we need to standardize? Maybe I'll try and simplify this a little bit more. I am so sorry, I didn't see carefully. Yeah.
Oh, it's okay.
Yeah. Oh no, let's try and solve this. So 0.9 bring over, we get negative p less than negative 0.02 minus 0.9. This gives me negative 0.92. Okay, simplify it down to negative 0.92. Then I times -1 on both sides. So what happens to my inequality? I have to flip the direction around. Is this okay?
Yeah.
Can okay, good. Then plus p of other guy, same thing. You'll just get p to be less than 0.92. Is that correct? Yes.
Yeah.
Okay, good. Wait a minute. That is a bit odd. Hold on. Okay. Wait. Something is wrong with the calculation. Hold on. Okay, you want the difference to be more than 0.02. So it's less than negative or more than positive. Then if you just solve for p here, you end up with p more than 0.92 or p less than 0.92. That would add up to 1. That doesn't make sense. Maybe they didn't ask for. Oh. Did I solve it wrongly? Wait, hold on a second. If you differ from, did I calculate wrongly? Sorry. Oh, right. Oh my goodness. No. 0.88. Is that better? This should be 0.88. Let's do it step. Is it clear? Okay, not clear. Let's just write it down. 0.9 minus away p more than 0.02. Solving for P, what do I do? -9 leave alone. 0.02 bring over become -0.02. More than negative P bring over become positive P. Flip it around. P is less than 0.9 minus 0.02. I just read it from left to right, then now it becomes right to left. So P is less than 0.9 minus 0.02, which is P less than 0.88. Right? Okay. Good. Much better. Equals 0.022. Okay, Ken. Now, do we know what is the distribution of P actually? What is the distribution of P? Yes, we do over here. 0.9, 0.005 square. But actually that is no longer true. What's wrong? In part 3, what changed?
The mean.
The mean? No, for P itself, not 0.9 minus P.
The diameter.
Not the diameter, no. I mean the mean of the diameter. The diameter is a thing we're focusing on. But that's not it. I mean, this entire question is talking about diameter, but that's not what I'm talking about. I'm saying from part 1, change to part 3. Something happened to your P. Is it still n 0.9, 0.005 square? Hint. Why did I write this at the side just now? What is this symbol?
The standard deviation.
Read the question. What did they ask for? Find the standard deviation that should be set. So here, standard deviation 0.005. And that's that's our answer. Is it correct?
No. The
So what's
standard
wrong?
deviation is unknown.
Very good. Yes. Okay, maybe I should have written that down at the side. Unknown. Okay, it is currently unknown. So we sort of reverse back into an unknown sigma square. Okay, so now our current, where should I write this? Sorry, I have to remove all this already. Yeah, I'm just gonna remove it. I have to restart. I'm so sorry.
Okay.
Yeah, sorry. This graph has to be gone. I'll draw it again later. So what we need now is probability. We need to figure out what's a distribution of P. So I'm just going to write it at the side. P here follows a normal. The mean is still the same, okay? We're focusing on the diameter. P represents diameter of pencil. Then this 0.9 is the mean of that diameter. And then the sigma square, because the question asks us to find the better value of sigma to maintain the 2.2% substandard pencils. Substandard means the diameter more than 0.92 or less than 0.88. Too big or too small? Too big or too small? 2.2%. Is that okay?
Yeah.
Does it make sense or not? More than 0.92 means it's too big. Less than 0.88 means it's too small.
Yeah.
Then the probability of each of them you add together gives you 0.022. Oh yeah, just one more thing to take note. Maybe it would have been better if you didn't use the random variable letter P. Because actually, right, when we pick a random variable here, it should always be capital letter. Okay, that's the first thing. And if you are using capital letter, there will be a clash with the probability symbol, right?
Yeah.
So that means that P is a bad letter to use as a random variable. Here, when you at the beginning, let diameter of pencils be P. I should have mentioned this at the beginning. You shouldn't use the band letters. Band letters or already got reservation. You cannot use. Not X. X can. Depends on the question. P because it's already used for reserved for probability. B because it's reserved for binomial. What else? N because it's reserved for normal distribution. What else? Mu and sigma, Greek letters, because it's already reserved for mean and standard deviation. What else is band? Capital E because it's reserved for expectation. Anything else? F. Don't use F as well, because outside of your syllabus, but it's another distribution that's resolved. F is something else. Don't use chi-square as well. If you study biology, you should know, right? Chi-square distribution, O minus E.
Yeah.
Not before over ER, this one. Yeah, that one is person. Okay, whatever. I don't teach bio. It's okay. You don't need to know this. Just don't use this symbol. Okay, these are banned symbols. You are not allowed to use. Not then, and also make sure that you must also follow the rule. All random variables must be capital letter. Okay, it has to be a capital letter. No small letter allowed. Also, this one, try to stick to single letter. So typically we just use X and Y, X, Y, or Z. All right. Of course you can use other letters like C or D. After cannot A A maybe can A maybe can. Is there any confusion? Yeah, don't think so. Okay.
Yeah. Okay.
Yeah. All right. Can but never mind. We just actually not so good to use P. Maybe I just change it to X. Is that okay?
Can.
We haven't used X at all. So we're just gonna use X instead. Okay. Can everywhere that I see P, I'll change it into X. Distinguish it from the probabilities P. We are changing the random variable X. Is that clear?
Yeah.
Okay, then here I should also change everywhere there was a P, I change it to a X. Okay, capital letter X. Can okay, one more. Okay, here. And I think that's all, I hope. Yeah, okay, that's all. Okay, good. So now we know the distribution of X, right? The pencil's diameter. It's normal. The mean is 0.9 and comma sigma square. How do we continue? How do you solve for the sigma? Well, you gotta involve the sigma here. So what should we do? Can we do something about it? What should we do?
Standardize.
Standardize. Okay, so let's standardize it. What do? It becomes P of Z more than 0.92. What do? Minus?
Mu over sigma.
Yes, correct. So Z is always equals to the X minus mu over sigma. So 0.92 minus away mu, which in this case is 0.9 divided by sigma. Likewise for the other guy, 0.88 minus away 0.9 divided by sigma equals 0.022. Okay?
Yeah.
Okay, trying to make it look nice. Okay, then after that, how do you solve? How to solve? Can you combine them straight away? Cannot. What do you do? Maybe we try to simplify this down a bit more. We try to simplify it down into Z more than 0.02 over sigma plus P of X less than negative 0.1 over sigma. Is that right? Oh, sorry, 88 minus 0.9. That would be negative 0.02 over sigma equals 0.022. Okay?
Yeah.
Then now we draw a graph. So X, sorry, it's not X anymore, it's Z. Yeah. We standardize, Can? Is it okay? Minus mu over sigma. Okay, then we simplify. So now that we get this guy, standard normal distribution, draw the bell curve. Where is its mean? This vertical line is X equals to what? If this is the X-axis. X equals to what?
0.
0. Very good. So that means that we want more than 0.02 over sigma, less than negative 0.02 over sigma. Can you try drawing on the graph? Sketching on the graph. Where is my 0.02 over sigma? And what's the corresponding P of Z less than, more than 0.02 over sigma? More than. Okay, I write it down for you. Good. 0.02 over sigma, then?
Leave the
P means
negative.
okay, good. Sorry, what? Then how about P of? So you're finding what? Area, right? And there. Those two areas added together will give you?
0.022.
And what else do you notice about these two values now? Now that I have corrected my mistake.
They are the
You re-
same.
They are same but opposite sign, huh? So it's symmetrical, right? They are reflections about the x equals 0. So that means that the area of these two are the same, right? Oh, that's what you're answering, is it? The area is the same.
Yeah.
Okay, good. Yes, correct. Good. The area is the same. So that means that each area you can just divide by 2 lor. So it's 0.022 over 2, which is 0.011. Likewise over there. Okay, good. Now how do you inverse norm? How do you inverse norm? Right, step 2. Use GC inverse norm. You need this format, right? In the middle.
Yeah.
How? What is question mark number 1, question mark number 2?
The PZ less than 0.011. Less than negative 0.02 over sigma is equals to 0.011.
Very good. Yes, probability should be outside. This is the x coordinate. Maybe I label for you. This one is the x coordinate. This guy is the area. Okay. Like the area. I mean, I color it in, I don't know, orange. Oh. Okay, then the x coordinate is this purple one. Is it okay?
Yeah.
Clear? Good, good. Then now finally we can proceed inverse norm. So inverse norm. Okay, let me show you. How do you inverse norm this? Second, go to the home page, main page. Then after that, second distribution, go to inverse norm. What's the area? Right hand side, 0.011. What's the mean? I forgot. Let me see. Oh wait, this is our standard normal, so 0.1 only. Okay, then we enter, and we get our answer. So that answer is negative 2.29. What is it equal to on the left hand side? Is it sigma?
No, it's the negative 0.02 over sigma.
Very good. Then after that, you solve for sigma. Okay, so that means you just take negative 0.02, divide by negative 2.29036. Okay, good. Good. So negative 0.02 divide by the answer. Then you get this guy. So sigma is 0.00832. Okay, then 3SF 873. Let's see if it's the same answer. Yes, correct. 0.00873. Okay.
Yeah.
Can okay. Good. Then I think that's what they did, Oh, they realized actually it got special trick. P of Z less than negative, P of Z more than positive is just 2 times of P of Z less than negative because their areas are the same, equals 0.022. But at the end of the day, yeah, we'll get the same conclusion. P of Z negative 0.02 over sigma equals 0.011. Can? Okay, good, good. Moving on. Okay, question 13. What happened? Let's read the question. Telecommunication telecommunication company finds that the duration of calls made by its customers to city A normally distributed mean 8 minutes, standard deviation 1.5 minutes. Duration of the calls made by its customers to city B normally distributed with mean 10 minutes, standard deviation 1.8 minutes. Find the probability that the total duration of 3 randomly selected calls to city A differs from the total duration of 2 randomly selected calls to city B by more than 3 minutes. Here, when you say differs, it's not really plus minus, it's more like absolute value. Okay. Question mark, minus question mark. Okay, so now let me see. The total duration of 3 randomly selected calls to city A differ from the total duration of 2 randomly selected. So here you have to be a bit long-winded. You should let exactly what you did here. X denote duration of calls by people in city A. Likewise, Y for city B. Very good. Good choice of X and Y. Okay. Then after that, it just follows this distribution: mean and standard deviation square, mean and standard deviation square. Good, good. Then you want to make sure you have indexes, because these 3 randomly, they didn't tell us that they are related to each other, whether they are exactly the same. They are actually, by assumption, we will assume that they are different. Okay, we will assume that they are different. So it's x1, x2, and x3. Then this 2 randomly selected calls to B will be y1 and y2. Is that what you did? Very good. Okay, then the difference, you take the absolute value is more than 3. Very good, that's correct. What's wrong? Why circle? Your setup is fine. Okay. Wait. What's this? You get an aura. Okay, take note that when you are using aura, you are describing events. So the only place where you can put the or is in between the brackets of the P. P open bracket, close bracket. This is the home of this is like the ocean. Then you have a lot of fishes inside. The fishes are like your events. The fish out of water, the fish will die. You put an or that only belongs in the ocean, it will not be valid. Okay. So what's the proper notation? Remove this bracket, or you keep it. If you want to use or, you're supposed to write it. Okay, I'm just going to rewrite the whole thing. Equals to P of, without the absolute value you want to open up, right? You just copy and paste that random variable minus y1 plus y2. Of course, later we can distribute less than -3, or copy and paste the entire expression, but change it to more than +3. Yes, it is long-winded, but no choice. That is math notation. Okay, then after that, because they are disjoint events, or means you can split it into a plus. So equals to probability of the first event. Can I just draw this? You can copy it down later.
Okay.
Plus P of same thing, but more than +3. That's how you split it up. P open bracket, this guy, plus P open bracket, close bracket of that other guy. Okay? Can? Good. Then after that, you just need to now calculate what's the expectation and variance and conclude. So let's see, expectation 3x minus 2y. Okay, you shouldn't do this. No, wrong. Different. No. Here, variance also wrong. No. I went through last week already. What's the difference? 3 and 2 in front. What happens? You'll end up with a 3 square and a 2 square. How come you're square on the wrong guy? Okay, there are, your mistakes is 2 layers. Let me show you the correct way to do it first. Okay. You're supposed to take variance of literally no shortcut, all the indexes copy paste, no choice. Sorry, a bit long-winded, but no choice. I have to do it. Then variance of independent events, you can sum them together. So it becomes variance of x1. Okay, this step may be optional if you can do it in your head. Variance x1 plus variance x2 plus variance x3 minus away. Sorry, we should open up this bracket. I'm just going to skip a step and open up the bracket first. I hope you're not confused. minus y1 minus y2. Then I open up the bracket. It becomes a negative coefficient in front, so I plus a negative 1 square times variance y1 plus a negative 1 square times a variance y2. Now I put bracket like this is to tell you it's optional. You can do this inside your head. I'm sure you know there's a negative 1 square, right? The square only applies to the coefficient in front of the random variable, not to the variance itself, right?
Yeah.
Remember, variance bracket a times x equals a squared times variance x. Did I square the variance itself? No, huh? Okay, good. Oh, wait, here, it's standard deviation square, is it? 1.5 square, 1.8 square. Okay, good. Can. Then over here, let me see. Oh, okay. Sorry, your mistake is not 2 layer, only 1 layer. Can. Variance x1, variance x2, and variance x3, because we are assuming as a hidden assumption that xi's are IID, independent and identically distributed, right? Just now I mentioned.
Yeah.
Which means that they all follow the same distribution, which means that they have the same variance. Oh, this guy here, 1.5 square. So it's a coincidence that it's a 1.5 square plus 1.5 square plus 1.5 square, 3 of them. That's why we have 3 times of 1.5 square. Plus, here is negative 1 square, it becomes positive 1. So it's just variance of y1, which is over here, 1.8 square plus another copy of 1.8 square. Which happens to be 2 times 1.8 square. Okay, so your answer is correct. But the presentation, you cannot summarize it as 3x minus 2y. Why? Because the variance of 3x minus 2y, you have to interpret it as variance, you will have to interpret it as variance plus negative 2 times of y. And then you split it up because it's independent. So variance 3x plus variance of negative 2y, which means you'll end up with what? 3 square times variance x. Okay, if you wrote this down, the internationally, people who don't speak English, you will see this. We will actually not just English, any language, you see this international math notation. You think of it as 3 square times variance x plus negative 2 square variance y, which is totally different from your answer.
Oh.
Right? Remember the coefficient factor out square, coefficient factor out but need a square. I proved it to you last week. Last week.
So
your notation here illegal, but your final answer here is correct. You cannot write down as summarize 3x minus 2y. You need to write down x1 plus x2 plus x3 minus 2 minus y1 minus y2.
Oh, so there's no way to write it shorter. You must write everything. Oh, okay.
So there is. You do mental sums as a scratch work, and then you present the final correct answer. What is the final correct answer? It's just the expectation here, which is 4, okay, and the variance here, I will assume it's correct. Then you can just, instead of writing down expectation here and variance here, you can just write down, you can write down over here like this, but yeah, shortcut is also not very short, No choice, you need to rewrite this part here as x1 plus x2 plus x3 minus minus y1 minus y2. Follows this distribution. Hey, forgot a letter n, very important. The distribution, is it n or is it binomial? Normal or binomial, must make sure you distinguish. Very important. Okay, missed out n. Okay, good. That is variance. Are we done? No, we need to answer the question after we found the distribution. So 3 calls were made. No. What question? So find probability that the total duration of blah 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 differs blah 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 by more than 3 minutes. Okay, so this was the probability we were trying to find over here, right? And we did so much work just to find the distribution of this guy. Now we can use our work. Less than -3 plus more than 3. So again, the notation is illegal. No, cannot. Write it out. Okay, I'm just gonna copy and paste it for you. Copy and paste. Huh? No choice, must write it out. Of course, alternatively, you can do something that you did before. Let D equals 2. Right? I think you did that previously.
Yeah.
Can let D equals 2. Then you don't have to write so much. subsequently, you can just substitute in with D. Also, instead of writing all this out, you can just write down D. But writing it as 3x minus 2y is illegal. And also, how come your 2y suddenly become 3y here? I don't know. Okay, but it shouldn't be there. It should be a D. Okay, anyways, should be x1 plus x2 plus x3 minus y1 minus y2. Okay. Can? Can. Yeah. Then after that, you just calculate the probability of them individually. Can refer to the solution. I think it looks nicer. Yeah, you see, they wrote it down manually. Never summarize it as, okay, I should write down x1 plus x2 plus x3 minus y1 minus y2. It is not equal. It is not equal to 3x minus 2y. Very important. Very important. 3 times of a particular guy versus individually add them together. The variance is very different. The variance is very different. That's why you cannot mix them up. See, they wrote it down manually 2 times. You must do that. Or you let D equals to that distribution. And then you can write down D less than -3, D more than +3. Probability bracket. So on and so forth. Oh, do I need to show you how to calculate this?
No.
Don't need, Okay, good. Now move on to part 2. What happened to part 2? Part 2, is it correct? Do you mark it? Part 2, 0.659. Yes, you got it right. Okay, then I don't look at it. How about part 3? Part 3 circle. Okay, let me just read the part 2 first. Maybe related. Okay, company charges rate of 22 cents per minute for every call to city A, rate of 30 cents per minute for every call to city B. Part 2, find probability that the total cost of one call made to city A, one call made to city B is at least $4.50. Let's see your working first. So you take the price per call multiplied by number of calls for X and for Y, and then you add them together. You want this to be more than 450. So you try to calculate expectation and variance. Okay, Ken, final, but I strongly advise you to go and present it in this, where is it? Where did I write it? I didn't write it. Oh, sorry, I didn't write it. Let's go back to part 1. For part 1, I want you to present your final answer as, like, for example, D, since I already used D, N of, write down, summarize the mean and the variance. 4,13.23, like this. Summarize it like this, so that you are clear of what is the mean and variance. Okay, then after that, part 2, same thing. Expectation and variance individually, okay, but you should summarize it. So you get the 0.22x plus 0.30y follows normal. 4, is it a 4 or 9? I think it's a 4. And 0.4005. Okay. Can Yeah, this is for part 2. Okay, then subsequently you just calculate that probability. Okay, can. Good. Now part 3. 3 calls were made to city A. Did they say 3 times of one single call, or is it 3 separate calls?
3 separate calls.
Separate calls. When they say 3 calls, it's 3 separate calls. So you have to make it x1, x2, and x3. Index. Now find the probability that exactly one call costs more than $1.80 and exactly one call costs less than $1.70. Okay, so let me write down x1, x2, x3. I see 3. I was thinking n equal to 3. Maybe it's binomial distribution. Could it be? Don't know. Let's think about it. Let's read the rest of the question first. Find probability that exactly one out of those 3 calls costs more than 180 and exactly one call costs less than 170. So what's the requirement for binomial distribution again? Can you recite for me the 3 requirements?
And independent trials.
And independent trials, yes.
The probability stays constant for each trial.
What of each trial?
The probability of success for each trial.
Success of each trial, yes. But if there's success, there will also be
failure.
Can there be 30% success, 70% failure? 1%? Like Different percent? Can it be? Maybe in between success and failure got success or phases. Is there something that's a mix in between of those two?
No, so there's only two
Only
possible
two
outcomes.
mutually exclusive outcomes: success or failure, nothing in between. Okay? No success or phases. No such thing. Okay, just success or failure. Right? Those are the three conditions. Very good. Look carefully at this. You have exactly one call cost more than 180, exactly one call cost less than 170. If you want success and failure, that means that you have to get this entire thing as success. Then what's the failure? Then what's that probability?
The probability is unknown.
Unknown no lah. N when you see N it's like intersect, right? Two events intersecting.
Yeah.
So you probably need to plus minus times or divide.
Times.
Times, yes. So exactly one call costs more than 180 means we'll have actually more than one. More than one. Means it's an inequality, right? Then exactly one means equal to one. If you want to combine this all into one single event, right? I think it's actually possible, but I think it's more simple to think of this question as just a normal probability question. If you think of this as binomial, can but the event is this super long-winded event. Okay, but don't need lah. Let's just think of this. Let's just calculate the probability of this event. Exactly one. Sorry. Oh, sorry. More than 180 is inequality, but actually, yeah, does it make sense? Yeah, it's an inequality, right? So how do you calculate that one? What random variable would you want to introduce?
Like what letter?
Yes.
Like W.
To represent what?
To represent the probability that exactly one call costs more than 180 and exactly one call costs less than 170.
Oh. How would you phrase that then? I mean, what's the distribution of that? Normal? What's the mean? What's the variance? How do you calculate that? You can't really do that.
But I thought it's just probability question.
Yes, but with distribution involved. Okay. Let's think of it like this. There is one event here, right? Then there's a certain probability. Yes, it's just a probability question, but the probabilities themselves, you need to use distribution to calculate. The P bracket X more than or P or less than or equals to some number. Now that's one probability. Then after that, there's another event, exactly one call cost less than 170. That's another guy, P of X, something more than something. And then you multiply them together. Right? Okay. Then how many, but then we have to arrange it in a few different ways, right? 3 calls were made, but they only specify 2 of them. So how do we arrange it?
But then the last call doesn't matter.
Then
how to do the third call?
Yeah, the last call doesn't matter. So that means we only need to arrange the 2 calls. Right? So there are 3 calls. There's one distinct call, there's a second distinct call, and then there's the third one that doesn't matter. But it has to be probably distinct, right?
But I thought the third call cannot be more than 180 or less than 170.
Oh, right. Oh, exactly one. So the third call, actually, there is a condition. Sorry. So it cannot be more than, cannot be less than. So the third call actually has a condition that has to be less than 180 and more than 170. Correct? In between 170 and 180.
Yeah.
Okay. That's good. That's good. Here, the three calls are actually we can just call them. I already wrote it down here as x1, x2, x3. So that means that over here, here, and here, we just fill in x1, x2, x3. Let's try and figure this out more precisely. So the first condition, exactly one of them. So let's just say it's x1. It costs more than $1.80. So more than 1.8. Okay. And why did I use x is because you use x here. X to represent the city A's cost. Then you multiply it by what? Multiply it by the second call. What's the second call's condition? Exactly one call is less than 170, so x2 less than 170. It has to be different now because if one guy, the first call is more than 180, it cannot be the same as the other guy that's less than 170. Oh, so it's a distinct call, x2. Then after that, you want to multiply it by the third call. Because the third call cannot be it has to obey this exactly one rule. So it means that it cannot be more than 180, cannot be less than 170. The only conclusion is it's in between. It's in between 170 and 180.
Yeah.
But that's x3. But then how many ways are there to arrange this? Call 1, call 2.
Factorial.
3 factorial ways. Yeah, actually that's true. 3 factorial. Multiply. Do you need to care about the order?
Yes, because they are distinct.
Yes, should be. Let's see the answer. They do the same thing. They are distinct calls, so they should care about the order, I guess. What is this question?
13.
13 part 2. Okay, not part 2, part 3. Yeah. Is it right?
Yes.
But actually, they didn't use X. Sorry, I forgot to account for the cost. They use C for cost. Because what I just used in my answer was wrong. I use X. X represents what? X represents the duration of call. But here they are actually focusing on what? Not just the duration, but the cost. So I need to multiply each of my. So I actually should create a new distribution. Sorry, I didn't think of that. But the cost, which is the rate per each call, which is in city A, I call towards city A. What was that cost? Where is it? 22 cents per minute for every call to city A. So it's $0.22 multiplied by number of calls. Let's just call that X. Yeah, you call it X, so that's why I follow. Okay. Then after that, this instead of X1, X2, and X3, it should change to the cost. C1, C2, C3. Is that okay?
Yeah.
But since this is a new random variable already, we need to calculate its distribution. So it has to be normal. Then you can actually just fill in the blank. Don't need to write it separately. What's the expectation? It will be 0.22 multiplied by expectation of X, which is what we have as 8. Then the variance, variance will be 0.22 factor out, then you need to square it, multiply by variance of X. Do you agree?
Yeah.
But variance of x we already know from what you have written over here. Standard deviation then square 1.5 square. Can? Just squeeze everything like this. Something, comma, something. All right? Good. Then from there, we can go and sub in and use by what do you call it? CDF, normal CDF to go and calculate this. Is that okay? Part three?
Yeah. Can.
Okay. Good. Good. Now part 4. John is planning. Wait, actually it's a part 4, okay. If it's okay, I skip. It's okay.
Yeah.
Can skip. Go. Question 14. Every morning, Peter has to take a bus to school. On average, he reaches the bus stop at 6:30 a.m. each day. His arrival time at the bus stop is normally distributed with a standard deviation of 10 minutes. The first bus will leave the bus stop at 6:40 a.m. sharp. Second bus will leave at 6:50 a.m. sharp. Regardless of the time the buses leave the bus stop, the bus journey will follow a normal distribution with mean 45 minutes, standard deviation of 20 minutes. Peter will be late if he arrives at school after 7:30 a.m. or if he misses the 6:50 a.m. bus. Assuming that the time Peter reaches the bus stop and the time taken for the bus journey are independent, find the probability that Peter will miss the 6:50 a.m. bus. Wow, a lot of things to digest. Did you try the question?
No.
Oh, okay. Can. Let's think about it. Take a bus to school. He reaches bus stop at 6:30 a.m. each day. Arrival time normally distributed. So let's just define the arrival time. Let's call it X. So X follows normal distribution with a standard deviation. His arrival time. So this one on average is 6:30 a.m. So arrival time. Let's see. Is it a smart idea to put 6:30 here? It's a bit funny to put time here like this.
Yeah.
Arrival time is a bit of a funny random variable to define, so probably not. So maybe we leave it alone first. Let's continue reading. First bus leave bus stop 6:40. Second bus leave at 6:50. Regardless of the timing the buses leave the bus stop, bus journey will follow normal distribution. Okay, let's define the time taken for the bus journey. Let's call this Y. Then they say it follows a normal distribution with mean 45 minutes, standard deviation 20 minutes. So variance is 20 square. Peter will be late if he arrives at school after 7:30 a.m. or if he misses the 6:50 a.m. bus. Let's see. So let's draw a timeline first. This is 6:30 a.m. Then he will be late if he arrives after 7:30. So to the right of 7:30. Or if he misses the 6:50 bus. So here is 6:50. He missed the bus. What does it mean? Maybe instead of talking about arrival time, we should talk about duration that Peter takes to travel from his house towards the bus stop. Towards the bus stop, yeah. Is that a smart idea? Let me think a bit. Actually, can I use 6:30? It's a bit funny. Arrival time, can I use it as a random variable? Actually, maybe you can. Maybe you can. It's just a bit not normal. Oh, what did they do? Number of minutes after 6:30 a.m. Peter takes to reach the bus stop. Right. Okay. Let's just follow the solution. This one, so simple, so short. Okay, so let X be the number of minutes after 6:30 a.m. So on average, he reaches at 6:30 a.m. itself. So the number of minutes will be on the mean of the number of minutes must be 0. 6:30 minus 6:30, the duration is 0. So the mean is 0 minutes. If you let x be number of minutes after 6:30 that Peter takes to reach the bus stop. Then they tell you there will be a standard deviation of 10 minutes. So there will be 10 square for the variance. Okay, then the first bus, okay, let's read the question first. Find the probability that Peter will miss the 6:50 a.m. bus. So that means if you miss the 6:50 a.m. bus, it means that how long do you take? How long do you take if you miss at 6:50? Means he took 6:30 until 6:50, 20 minutes to travel to the bus stop. More than 20. Is that clear?
Yeah.
The travel time here is 20 minutes. If you take more than 20.1 minutes, the bus leave already. Then you have missed the bus. So it should be more than 20. Of course, this is normal distribution. So exactly equal, the boundary case where it's exactly equal, you don't really need to care too much. All right. So Px more than 20. Then we know this follows normal distribution. So we can just use a CDF, use right tail area, or 1 minus the left tail area. Then you can get the answer. Sorry, actually, I don't need to think about left or right. Just pick the lower and upper to be 20, then this one E99. And the mean and the variance, so I mean standard deviation, is just 0 and 10. I'll key in the GC and you'll get your answer. All right? Okay, good. Can now part 2. Show that the probability that Peter will be late for school is 0.42. Late for school, there are 2 cases, right? You either arrive at school after 7:30. In other words, he took more than 20 minutes to travel from his house to the bus stop, or if he misses the 6:50 a.m. bus. Okay, so there are 2 parts to this. You either, okay, I draw the timeline. Let me copy down the timeline to the answer. I think it's easier. Okay, you either reach the bus stop late, so 6:50 a.m. Definitely not enough time to travel for the bus to travel from the bus stop to the school, or your duration of the travel time is too long. It's more than the difference between the not the difference. I mean the time till 7:30. But from the time the bus leaves bus stop. Right?
Yeah.
And there's a hidden assumption. It means that the moment Peter reaches the bus stop, then there's a duration from the time he reaches the bus stop to the time that the bus comes, and then the bus travels. There's an additional waiting time, right? When he reaches the bus stop, he has to wait and he has to queue up for the bus. But we're gonna assume that that's also included in a certain random variable we're gonna come up with. So we shouldn't mention time that bus leaves bus stop. That's too precise already. From the time that Peter reaches the bus stop. That is good enough. Okay. So imagine the scenario. He reached the bus stop. Then he wait. And then he queue up to enter the bus. Then the bus leaves and travels on the highway to the or somewhere along the road to reach the school. So there's the first half of the journey where he waits. He queue up for the bus stop. And then after that, the bus finally arrives. He gets on and he travels. I mean, the bus moves. Bus moves. Don't need to think so precisely. Just lump them all together into one. Then this will be the time that is spent from that will be the duration from the moment Peter reaches the bus stop to the moment when it's 7:30 a.m. When will Peter be late? It's when this timer is more than, okay, this is the remaining amount of time. It's when the travel time of the bus is more than that amount of time. Does it make sense?
Kind of.
Okay, let's read the solution. Okay, let's see. So let y be the number of minutes for the bus journey. Okay, then the probability that Peter will be late for school is when the first part, he misses the 6:50 a.m. bus. And for the next part, he did not miss the bus. Okay, maybe I draw a tree diagram. Miss 6:50. Yes or no. Result, he's late. No, then you have two possibilities. Now you have to ask did he is the travel time more than, how much time is it? What did they mention? Arrives at school after 7:30. The bus leaves at 6:50. Wait a minute. Let me think a little bit. Why did they mention 50 here? I'm a bit confused. He reaches the bus stop at 6:30 a.m. Then the next part, the first bus will leave the bus stop at 6:40 a.m. sharp. Second bus leaves at 6:50 a.m. sharp. Right. Oh, okay. So okay. So there are two buses. Sorry, I forgot about the 6:40 bus. Okay, so let's look at the timeline again. I forgot to account for the 6:40 bus. Here is 6:40. There is a bus number 1. It will leave at 6:40. Then you travel until 7:30, the deadline. The time when you are late. Then after that, the second bus, this is bus number 2 at 6:50. So he will start from here and travel until 7:30. So when will he be late? It's when both buses are the duration spent traveling is more than the remaining amount of time available. When will he be on time? Let me see again.
But they say he will be late if he misses the 6:50 bus.
It means that the travel time of the bus in this case is 40 minutes, right? So it means if he actually catches the 6:50 bus, he will spend 40 minutes he has 40 minutes of time to travel, and that will still allow him to be safe, right? It will allow him to reach on time. So the moment it exceeds 40,
but the bus journey is 45 minutes.
On average, the mean. That's just telling you the distribution. It doesn't mean that it must take 45. Sometimes it can be faster. So okay. Let me think about this. How do I say it nicely? If he missed 6:50 bus, he is late. So I think this is indirectly telling us that from the 6:50 timing when he takes that bus. It arrives at 6:50 until 7:30, which is the time when he will be late. This duration is 40 minutes, right? This 40 minutes is the amount of time that he has in order to not be late. If he spends less than 40 minutes, I mean the bus, less than 40 minutes traveling, Peter is safe. Does it make sense?
Yeah.
He got 40 minutes to travel. Of course, less than 40, even better. Right, the boundary case, we can think about it later, but less than 40 minutes definitely will reach on time. So when will he be late? Late means the opposite of on time, right? So the opposite of less than 40, which is?
More than 40.
So if the bus spends more than or equals to 40 minutes traveling, Peter is late. Opposite. Can?
Yeah.
Okay. Yeah, I think this is quite challenging. Okay, you must think carefully about the scenario. The second bus timing until the time that he is late, 40 minutes travel time is the maximum that he has to be on time. So once he exceeds the 40, he will definitely be late. But of course, at the boundary case, more than or equals, maybe I think he will also be late, exactly equal to 40. But of course, it doesn't really matter. Why? Because the bus spends, the amount of time that the bus spends is a normal random variable. Okay, it's a normal random variable, which is a continuous random variable. So the boundary case where it's exactly equal, it will just contribute to a probability of 0. So we don't really need to care about the boundary. Okay, you know what? I'm just going to erase the boundary case. Just put it strictly more than. Is that okay?
Yeah.
Can Yeah, so now let's look at the tree diagram of possibilities. He missed the 6:50 bus. Yes, then confirm he is late. I'll put an L. Then if his travel time is more than 40 minutes, yes or no? If yes, if no, yes, then he will also be late. No, then he is safe. Do you agree with this tree diagram?
Yeah.
So now we want him to be late. So what's the probability? We have to take this branch, the probability, plus this branch probability. You just need to multiply these two events. And also, we do not need to assume independence here because I mentioned before, right? P of A prime, this is P of, what is it? Okay, I write it down. This is event A, this is event A prime. This is event B, this is event B prime. Then the probability associated with this, okay, no, I should mention this is event B here, and that is event no is event B prime. B prime. Then over here, event A is yes, and event A prime is no. So here the probability is P of A, there is P of A prime. They add up to 1. Then P of A prime, you branch out over here. This branch here, the probability is B given A prime. The other guy is P of B prime given A prime. A prime is the condition that happened in the previous level. This two will add up to 1. Then the overall probability here is P of A prime times P of B given A prime, which means you can just get the overall probability of P of A prime and B prime, and B, which means that he did not miss the 6:50, but his travel time is more than 40. And then for the other guy, likewise, you can have P of A prime and B prime, which is basically saying he did not miss the 6:50 bus, but his travel time. Oh wait, sorry, we don't want to look at the second guy. Sorry. We only focus on the cases where he's late. So these two cases. That's all we need.
Mm.
He missed the 6:50, then he's late, or he didn't miss, but his travel time is more than 40. Is that okay?
Can.
Can, huh? Okay, good. So that's why we got these two probabilities here. This part is when he missed a 6:50 bus. This part is when he did not miss the 6:50 bus. Oh, but his travel time is more than 40. More than 50? Hold on a second. Oh, you consider 3 cases? Let me think a bit. Oh, there are 2 cases. Oh, there are 3 cases to consider. You need to account for the amount of time that he took to travel to the bus stop first. It's either 10 minutes, less than 10 minutes, or in between 10 to 20 minutes. Then after that, you consider the time taken for that first bus, 50 minutes, or the second bus, 40 minutes. I was only considering the second bus. And that means the first bus traveling time is in between 10 to 20. Sorry. I'm getting confused for part 2. Wow, this is getting quite complicated. Right. Sorry, I forgot to include one extra event in between. Do you know what's the event?
No.
If he didn't miss the 6:50 bus, there are 2 cases to consider. 2 more cases, sorry, 2 times more cases to consider. He either he catches the first bus at 6:50, or he catches the second bus at 6:50. 6:40 and 6:50. Let me say again. If he did not miss the 6:50 bus, from here we need to branch out into 2 more sub branches. He either did catch the 6:40 bus, meaning he spent 10 minutes or less traveling towards the bus stop, or he catch the 6:50 bus, meaning that he missed the first bus. All right. So he will take more than 10 minutes to from 6:30 a.m. he left his house, 10 minutes to maybe 11 minutes to travel to the bus stop. And then he waited a bit more until he catch the second bus. Does it make sense?
Yeah.
Okay. Oh, this is getting very confusing. Let me try and explain this. Maybe I'll draw a timeline. I think I should draw a timeline. Wow, this horrible question. Okay, let's summarize what's going on first. So let's draw a timeline, make it neat. There's a 6:30 a.m. He left house. At 6:40 a.m. first bus arrives. At 6:50 a.m. the second bus arrives. At 7:30 he will be late. Okay?
Yeah.
Now there are a few possibilities. First scenario, he has to leave his house by what time again? Let's see. Let me think of it. First possibility is he left house at this duration here. X more than 20, meaning that where X is the travel time from, okay, sorry, not travel time, don't confuse. time taken to travel from house to bus stop. If he's left house at 6:30, if he took more than 20, x more than 20, it means that he only reaches the bus stop at 6:51 maybe and beyond. Does it make sense?
Yeah.
And also he misses both first and second bus, then confirm he will be late. He has to wait for a third bus, and there's not enough travel time to reach his school by 7:30. Okay, that's the first scenario. Miss both buses because why? Because he took too long to travel. Specifically, what do I mean by too long? He took more than 20 minutes to travel. He left house and he took more than 20 minutes. So he missed the second bus timing. Now the second scenario, he didn't miss both bus. He caught first bus. Okay, we're trying to consider all the possible ways. First one, second one, third one, all the possible ways such that he will be late. We're trying to, maybe I write down the objective. Objective. List all ways that Peter is late. Okay, then first way, second way, third way. I listed the first way, he missed both buses. He took too long to travel, to leave his house, and travel to the bus stop. Second way, he caught the first bus, meaning that what happens? Yeah. He caught the first bus, means that he reached at 6:40, right?
Yeah.
Reach at 6:40, which implies that X is less than 10 minutes. Or not reach at, not at. At means it's too precise. You can be early. You reach by 6:40. So you can be reach at 6:38 or 6:39, but you just wait 1 minute, wait 2 minutes, and then you catch the 6:40 bus. So that means X is less than 10, right? Because this will be travel time 10 minutes.
Yeah.
Okay, maybe I label here 10 and over there 20. Okay, but you want to make sure that you force him to be late. What happens? If he reach within 6:10, he catch the first bus, how do you make sure that he is late? Now it depends on the bus. We have to slow the bus down, force him to be late. So from 6:40 to 7:30, how much time is that?
50 minutes.
It's 50 minutes. Okay, good. So that means that if we want him to be late, we need this will be travel time of the bus. It has to be more than 50. Does it make sense?
Yeah.
So that means his arrow will be like this. He will take, then the travel time for the bus is more than 50 minutes. So he will only reach school beyond 7:30 a.m. Not beyond, at a time, reach school after 7:30. After 7:30. Does it make sense? This guy.
Yeah.
So that means in terms of a random variable, that will be what? That will be, this would be y more than 50. Is that okay? Where y represents the travel time taken by the bus. Is that?
Yeah.
Time taken to travel from bus stop to school. Yeah. Just now was house to bus stop, now it's bus stop to school. Okay, you have to take more than 50 minutes. And these are consecutive events, right? So that means that altogether, okay, maybe from altogether, we have P of X less than 10, and they are independent. So we multiply by P of Y more than 50. That's for the second scenario. He managed to reach the first bus on time. He take the first bus, but the first bus took too long, more than 50 minutes. Maybe there's traffic jam. Then therefore he became late. Is that okay?
Yeah.
For the first guy, it's just P of X more than 20. Then what's the third scenario? The third scenario, just now I forgot to consider the second scenario. The third scenario, I actually explained this already. This time, if he caught the first bus, we want something different. So he didn't catch the first bus. If he did catch the first bus, meaning this would mean that he spent less than 10 minutes to travel to the bus stop. So now, since he did not catch the first bus, how much time did he spend to travel to the bus stop? Would it be less than 10 or more than 10?
More than 10.
More than 10 minutes. So he didn't catch the first bus means that X will be more than 10, the opposite of less than 10 just now. Do we need to care about the boundary case exactly equals?
No.
No, don't need, because this is a random variable. Exactly equal, we are not going to be calculating the probability of an exact case where X equals to 10. That has no meaning. That one will just give you P to be equal to 0. So we ignore that case. Then that means that we have to go on to the next scenario. If he didn't catch the first bus, then now he has to wait for the second bus. He has to wait for the second bus. Yeah, just now at the first case, I already missed both buses, right? So it's a no and a no. Just now in the second case, you caught the first bus, then that means it's a yes, and you can ignore this case. It's not relevant to whether he caught the first or second bus. Now in the third case, we are saying he missed the first bus. Then what happens to the second bus? If you want something different, yes or no? Did he catch or not catch?
Yes.
Must be a yes, right? To make it different. So let me just draw a little diagram, a little tick and cross diagram. So miss both buses, then he became late. Catch the first bus, then this is irrelevant. But travel time of the bus more than 50. So he became late. Maybe I'll just move the late over here. And then the third case now, this is first case, there was second case. Now the third case is he failed to catch the first bus. Failed to catch the first bus means his travel time was more than 10 minutes. He missed the 6:40 bus. But now he caught the second bus to make it different from the first case. What does it mean if you want to catch the first bus? How much would his traveling time be? Can it be more than 20 minutes?
No.
So it has to be the opposite, which is less than or equal. So But then of course, since this is a what do you call it? Continuous random variable, so you don't have to consider the boundary case. Just less than 20 will do. Is that okay?
Yeah.
Very good. So he didn't catch the first bus, he caught the second bus, but we want to force him to be late, because that's what the question wants. Want to calculate probability of the events where he's late. So we are trying to list down the odds objective, list down all the ways that Peter will be late. So now the third scenario is miss the first bus, catch the second bus. Oh, then he'll be on time, right? No, cannot. We must force him to be late. So what do? We must force his bus to travel slowly. How slowly? What's the duration here? He will be on time if the travel time is 6:50 to 7:30 is 40 minutes. So we want him to be late. So what do we want for our y? Y being the travel time of the bus.
More than 40.
Very good. Yes. More than 40. Okay, so how do you combine all these three information into one? You will just have to conclude that first scenario is P of X in between 10 and 20. I mean, the first event. And then the second consecutive event is after this is the probability of him not catching first bus, but to catch the second bus. Then after that, a consecutive event is that he took too long to travel. Why more than 40? I mean, the bus took too long to reach his school. And we can just multiply because they are independent events. Is that okay?
Yeah.
This part? Then after that, these are three separate cases that have no overlap. So therefore, we can conclude that they are mutually exclusive, which means we can just plus them together. The probability. Therefore, the total probability will just be equals to this first guy, P of X more than 20, add on with the probability of the second event, add on probability of the third event. I'm running out of space. Let me move it down like this. Okay. Then you just type in a calculator. Does it make sense now?
Yeah.
Okay. Sorry. I should have started with a timeline. I never read the question carefully. I hope this answer is correct. Is it? Let me double check. Is it the same as the answer? Almost. They included an equal sign. Equal sign here and here. But does it really matter?
No.
No, it doesn't. Oh, no, it doesn't. Because this is just continuous probability. Okay. Yeah, Peter will be late. Wow, challenging. Is that okay?
Yeah.
Okay, good. Now, that's it for the normal, right? You didn't? Do you do supplementary? Oh, you tried the supplementary question.
Yeah.
Oh, okay, I can go through. Yes. Do you need to rush off?
Soon.
By what time?
Like 1:30.
Okay, can. This one could you do? 15.
I couldn't get the final answer.
Okay, can. Let's just read the solution now. I think it's faster. Okay, can. Let's take a look at the solution. Okay, let's see. The mass of sugar sold in bags is normally distributed with mean mu kg and variance sigma square kg square. You can ignore the units. What does kg square mean? I have no idea. It is known that 30% of the bags of sugar have masses which differ from mu kg by at least c kg. 30% here refers to probability, right? 0.3. So there's some probability of an event equals to 0.3. Then they tell you the event. Bags of sugar, masses differ from mu by at least c. What does that mean? How do you translate this into math notation? Differ from mu means you have to minus mu, right? Then
but it's plus minus.
Plus minus. Bags of sugar. So you should always think of difference as modulus, not plus, not just plus minus, but more importantly, modulus, absolute value. Is that okay? When you see differ, think of modulus. But here, bags of sugar have masses. So what should we do? We should let this guy, masses of sugar sold in bags, be x. That's what they do here. So we'll have x minus mu, differ. So modulus of the difference between them, plus or minus. So consider both plus or minus to be at least c. At least means what direction? Less than or more than? Which direction? Less than or more than? My test, I cannot hear.
More than.
More than, should be more than. Okay, at least c. Now you want to find, okay, they tell you it is 30%. So this guy equals to 0.3. How 30% is 30 over 100, which is 0.3. Find the probability that a randomly chosen bag of sugar has a mass which differs from mu kg by less than 2c. So randomly chosen bag, that's just x. We want this, or what do we want? Has a mass, so x is the mass. It differs from, so minus modulus, from mu, so that's a mu, to be less than 2c. Find this probability. How? So difficult because mu and sigma square are not provided. What can we do? So over here, when the mu and sigma is not given, you must always do standardization, right?
Yeah.
So recall what z equals to. Z equals to x.
Minus mu over sigma.
Very good. Okay, so you must start off with x following normal distribution mu comma sigma square. So you standardize, you minus mu divided by sigma. This will follow a normal 0, 1. Is that okay? Can now? Good. So now take a look at the distribution here. Okay, got modulus. We try to make things standardized. So let's just open up the modulus before we take the standardization. Over here, we can open up the modulus. So we get x minus mu less than negative c plus p of x minus mu more than positive c equals 0.3. Then we proceed to standardize. Notice that there's already a minus mu. So all that we need to do now is to divide by sigma, right? Okay?
Yeah.
Then that will be z less than negative c over sigma plus p of z more than c over sigma equals to 0.3. Now, what do we want to do? You have unknown sigma, how to solve?
In the inverse norm.
Inverse norm. But in this case, we will get c over sigma. But over here, it's different. One is more than, one is less than, but negative and positive. So draw the graph, right?
Yeah.
Inverse norm is only when you have a single p. Here got two different p, so we need to draw the graph of the PDF, the bell curve. So what you realize is that mean is 0, right? Because it's a z. So that means that, I should use a curvy x. Okay, this is the equation of a straight line, the y-axis actually. Then this is c over sigma, that is negative c over sigma. So less than is this area, more than is that area. How do you express it as a single expression?
Is 0.3.
Less than, sorry, what? Z less than what?
Z less than negative c over a is equal to 0.3 divided by 2.
Very good. Yes, 0.3 over 2. Because the areas on the left and on the right, they are equal to each other. This will add up to 0.3. Then you have to divide by 2 because of symmetry. Sorry, my diagram not so symmetrical. I hope you can tell.
Yeah.
That's supposed to be symmetrical. Okay, here it's not A, it's sigma. Sigma, not A. Okay, C over sigma. Good, good. Then inverse norm, what do you get? You'll end up with negative C over sigma equals to, let me calculate. Did you get the value? I should see inverse norm. So the area here is the 0.3 divided by 2. The standard form, so standard normal distribution. So the mu and the sigma is always 0 and 1 respectively. Paste it. You end up with negative 1.0364. All right. Good. But you realize there's an unknown, c, right? There's an unknown c. What can we do? Don't bother doing anything. Just leave it alone first. We'll deal with it eventually. And because, and actually we don't need to do with it too much. Because the question is actually asking you to find this guy. Can you see?
Yeah.
So you can just open up the modulus. Here, actually, in the solution, what they did is they just standardized straight away. But how do you know for sure that the inequality won't change direction? We haven't proved it yet. So we don't know for sure. It will be true, because but I think it's easier if we just use the trick that we have been doing so far. Open up the modulus first, then standardize, then look at the graph, and then you conclude. Convert it into just a single p using the graph. Is that okay?
Yeah.
Okay, good. So now do the same thing with this guy. So we're gonna open up this guy. What do we get? We'll get p of x minus mu less than negative 2c. Then we can standardize straight away. Divide by sigma, plus p of x minus mu more than positive 2c. Divide by sigma, Is that okay?
Yeah.
Then this will be equal to what? P of Z less than negative 2C over sigma plus P of Z more than 2C over sigma. So again, this will be, if you can just, if you just think about it a little bit, this will just be actually 2 times of P of Z less than negative 2C over sigma. Do you know why? I mean, yeah. Draw the graph.
Because the area is the same.
Yes, correct. Huh? So this is how the graph will look because it's standard normal. So mean is 0, it will be line of symmetry. Negative 2C over sigma is the left tail area here. And positive 2C over sigma is the right tail area here. And they will be equal because one is positive, one is negative. 2C over sigma, 2C over sigma. Then their areas are the same, so I can just take one of them, I times 2. I decided to take the left tail area, the arrow pointing towards the left, and I times 2. Now, how do I proceed? What you should realize is that negative 2C over sigma. That looks very familiar. Oh, right. I have a negative C over sigma here. How do I link negative 2C over sigma to just negative C over sigma?
It's half.
Half. But more importantly, we want to calculate this guy. So why don't we just substitute in? So it becomes not half, but rather 2 times of negative 1.0364. Makes sense or not? Okay, maybe my handwriting a bit too small already. Wait, hold on. Let me, not too small. I mean, the front part, I'm gonna shrink it down. I'll rearrange it later. Okay, I'll do it now. Then this guy, I'll just bring it on top. Maybe you cannot see that because it's too squashed. Okay, this guy, I rewrote it as 2 times of this guy, but you should realize immediately that this is 2 times P of Z less than 2 times negative C over sigma, right? This guy is this guy. Then you can just sub in, 2 times of negative 1.0364, which is exactly what they did over here, huh? They sub in that negative, okay, they didn't do it exactly. Never mind, I show you. So this will be 2 times, this will be equals to 2 multiplied by P of Z less than 2 times of negative 1.0364. Then this, you can just key in the calculator. Right? P of Z less than, just use the normal CDF. Is that okay?
Yeah.
Just multiply out this one 2 times. Okay, good. You get the 0.962. All right, next one. We'll see. I have to end by what time? Again.
Like 1:30.
Okay, can. The weights of, can I just continue? Can. Do you get the answer for this one? No.
No.
Okay, can. The weights of Sunny brand oranges, they are normally distributed mean mil grams, standard deviation sigma grams respectively. An inspection of a shipment of Sunny brand oranges shows that 37% of the oranges have weights exceeding 379. Yeah, so you got W more than 379, probability equals 0.37. That's fine. And 40% of the oranges have weights between 336 and 379 grams. So, you never, did you write down? You wrote down over here. How come you standardize with a Z? Yeah? That doesn't make sense. It's still the same oranges, still the same oranges. So it shouldn't be Z, it should still be W. Okay, it should still be W that's in between 366 and 379. Do you get what I'm saying? This 40% of the oranges is still referring to the original orange. So it's still referring to the original weight of the oranges, W. So it should actually be just P366 less than W less than 379 equals 0.4. Then after you wrote this down, you try and standardize. Minus mu divided by sigma. Okay, not Z. This is wrong. But this part is okay. This part standardized is okay. right? So yeah, you got your first equation in terms of mu and sigma here. Then from the other guy, you can also standardize and get another second expression for mu and sigma. So let's just quickly do that. What will we get? Z, which is minus mu over sigma, will be 379 minus mu over sigma minus mu over sigma. On the other side as well, 366 minus mu over sigma. Is this okay?
Yeah.
Can, good. So, okay, let's think about it. That's not an A. I'm so sorry. This should be a sigma. Like that. Okay. How do we solve this? Well, we know that this is Z, which has standard normal. Then from there, can we proceed? How do we proceed? Can we inverse norm? Can we inverse norm? Cannot, huh? How do we proceed? So from 366 to 379, that means that they are off by a bit. I need to use a symmetry argument already. In this case, how do you make them symmetrical? Let's just draw a graph. Let's draw a graph. Okay. So the x-axis is here. The z is about the y-axis, like this. Okay. Then mean is 0. Then you're trying to calculate 366 minus mu over sigma and 379 minus mu over sigma. Find out mu and sigma, get an expression. You know the area is 0.4. So 0.4 means what? Means maybe, for example, here to here, I'm not too sure. There will be 366 minus mu over sigma. 366 minus mu, straight up, not 66 anymore, 79 minus mu over sigma. That means that you got the area here minus away the area there equals to 0.4. How do we solve this? Okay, let me just take a look at the solution. I'm a bit confused already. Right. It was given already, this part. More than 379 is 0.37. Right, correct. Okay, so from the first part, we already know that the 37%, right? We know that P of X more than 379 is 0.37. So that means that over here, after we get our interval that's in between 366 and 379, you use W, right? Before we standardize, we can actually simplify this guy. P of X more than 379 is actually just 37%, 0.37. So minus 0.37, we can bring it over, it becomes plus 0.37. So you end up with 0.77. Okay?
Yeah.
Then after that, you proceed to standardize. 0.77 don't need to change. Only the inequality changes. X minus mu over sigma, 366 minus mu over sigma. X minus mu over sigma will just be Z. You end up with this. Is it okay?
Yeah.
Can, then from there, because it's just the standard format, maybe we just rewrite it as 1 minus first. So eventually you can simplify it down to this guy. Equals to 3. Right? Do you get how I went from this to this? P of just 1 minus because you can think of it like you have the area under the curve. Then we currently have a 366 minus mu over sigma. Here they tell you probability of Z more than this is 0.77. It really means, okay, maybe I move my graph around like this. Yes, much better. This guy 0.77 more than means the right tail area is 0.77. You know the total area is equal to what? Equals to 1. So that means that the left tail area, this light blue part, wow, my graph is very bad. The left tail area here, the blue part, light blue part, is really just this 0.23, the less than direction. Can see? Just take 1 minus. Then after that, you can inverse norm. Then you will be able to obtain an expression for 379 minus mu over sigma and 366 minus mu over sigma. Then you can form 2 equations here, and they did it here. You get 2 equations here and here, simplify it down into this guy and this guy. Then from there, you can do simultaneous equations. Okay. Do simultaneous equations, then you'll be able to solve for sigma. And sub in and you can solve for mu. Just use GC. This one don't need to do it manually. Just use GC. Okay, then after that, you get your required probability. How? It's the same situation again. Find the probability that 1 orange has weight exceeding 379 and 2 oranges have weights between 366 and 379. So you can just pretend that, not pretend, it's a hidden assumption under all questions. Assume that all of the events are independent. So you can multiply. 1 orange exceed 379 grams, so x1 more than 379. 2 orange have weight between 366 and 379. So you can have a probability of 366 less than x2 less than 379. But since these are 2 oranges and they have the same event, the probability, in terms of their probability, it will be equals to this guy squared. Okay. Right? The same probability multiplied together. So 2 of them, and that's why you have a square here. And then after that, because there are 3 distinct oranges, so we have to arrange them 3 factorial ways. In this case, do we need to care about the order? Do we need to care about the order? Not really, huh? Okay. Don't need to care about the order. So that means that we have to divide by 2 factorial. Is it right? Oh, no. Sorry. No. Let me try again. Okay, here the 3 factorial over 2 factorial is because there is first orange that's of a first scenario, then there's 2 oranges that's in the second scenario. Then we have to arrange them. We need to care about order, sorry. So it's actually 3 items here, 3 factorial ways to arrange, but 2 of them are under the same category. So we have to divide by repetition, 2 factorial. Does that make sense?
Yeah.
3 factorial for the 3 items, but divide by 2 factorial for the repeated items. Okay, can? Yeah, then you multiply out and then you get the 0.1776. Round off 3SF, get 0.178. Okay. Okay, good. Next. Do I have time? Oh, Krabby Island. Okay, I'm just going to go straight to the solution now. Okay, let's take a look. On Krabby Island, a fishmonger rears many types of live seafood in his kalong, one of which is a particular type of crab named hairy crab. Weight H in kg of a random hairy crab follows normal distribution with mean mu kg standard deviation sigma kg. Given that P of H less than 1.5 and P of H more than 3.5 equals 0.33, state the value of mu. Show that sigma equals to 2.27. Okay, this is a very similar question. You just have to use the average. Did you get the mu? Basically, there is a normal distribution. There is symmetry about the x equals to mu value, whatever that mu is. And the area towards the left and the area towards the right, if they tell you it's equal, like less than 1.5 here, left tail area, and more than 3.5 there, right tail area, if they tell you it is equal, it means that the line of symmetry must be the average of these 2 values, 1.5 plus 3.5 divided by 2. Is that okay?
Yeah, I got the...
You got the 2.5. Very good. Then now you want to show that sigma is 2.27. How would you do that? So here, when they tell us is 0.33. You can actually just standardize it, right? Then you take the inverse norm to solve, and you get the negative 0.43991. Here, why do you want to standardize? It's because mu, sigma, unknown. Okay, mu is known already, but sigma still unknown. Oh, maybe we can write down our distribution. H follows n of mu 2.5. Sigma currently still unknown, so sigma square. Oh, that's why you unknown here. That's why you have to do standardization from here to here. Is that okay?
Yeah.
Minus the way the mean 2.5 divided by the sigma. Then right hand side, leave it alone. After that inverse norm, you get the negative 0.43991, which will be equal to your fraction here. 1.5 minus 2.5 will give you your negative 1. That's why they have a negative 1 here. So negative 1 over sigma equals to that value. Solving for sigma, you get 2.27. Done. Sub in and you get 2.27 square. Oh. All right, so that is your H. Hairy crabs, the normal, the mass, the weight distribution. Now part 2. Find the probability that out of 4 randomly chosen crabs, 2 weigh between 1.5 kg and 3.5 kg each, and the other 2 weigh more than 3.5 kg each. So this is again a kind of probability question, sort of like counting and probability combined. Don't need to think about binomial, I guess. Among these 4, you have 2 of them weighing 1.5, 3.5. So that means it's 1.5 to 3.5 for the first guy and the second guy. Then after that, the other 2, what happens? The other 2, they weigh more than 3.5, more than 3.5. So H more than 3.5, more than 3.5. But there are 4 crabs. So you have to care about the arrangement. So 4 factorial. But these 2 are repeated. These 2 are repeated. So you just divide by 2 factorial, divide by 2 factorial. Account for the repetition. Is that okay?
Yeah.
Yeah, then the rest is just filling in the blanks. Sorry, I'm rushing a bit. I hope it's clear.
Yeah.
Okay, Ken, next question. Aiden, specimen paper, could you do this?
No.
No? Okay, Ken, let's take a look. Shopper buys 2 kinds of vegetables in a shop. The mass of potatoes and the mass of the onions bought are modeled as having independent normal distributions with the following means and standard deviation. Price of potatoes is 50 cents per kilogram. Price of onions is 120 per kilogram. Find the mean of the total cost of the vegetables. Show that the standard deviation of the total cost is 0.117, correct to 3 significant figures. Okay, so total cost of the vegetables, is it? That means we need to, let me think a bit. How many did they buy? This is the mass that they bought, huh? Okay, good. Then price of potato is 50 cents per kilogram and 120 per kilogram. So you need to multiply accordingly. So 50 cents is like $0.5. Must standardize into dollars, I believe. 0.5 multiplied by the mass of potatoes 3, then 120 multiplied by mass of onions. Then from there you can get your updated distribution. But of course, this is a random variable, right? It's not always 3. You can have some sort of variance. So that means that we will want to use a random variable to represent each of them. The mass of potato and mass of y, which is what they did here. Let x be the mass of potatoes, let y be mass of onions. So that means the mass, they follow a distribution. Each. This part okay, right? The distribution for the mass. Mic test, can you hear?
Can.
Can, the mass is okay. Then how about total cost now? Total cost, you just need to multiply each of these x and the y by their corresponding cost per kg, which is what they did here. 0.5 multiplied by x, 1.2 multiplied by y. Can? Good? This part? Just standardize the units to dollars. That's why you got 0.5. 50 becomes 0.5. 50 cents per kilogram. How many kilo? X kilograms. 120 per kilogram. How many kilograms? Y kilograms. That's why you multiply. Is that okay? Is that okay? Hello?
Yeah, can.
Can. Okay, good. So then okay. You multiply and you get your total. So now what they want the mean of the total cost, right? So expectation of t. So that means we can just take expectation of this guy. So it reminds you of binomial distribution already, right? That kind of question. Just linear. Just factor out the 0.5, factor out the 1.2. Then you sub in, what's expectation of x? It's just this guy here, 3. What's expectation of y? It's just this guy, 1. And it's actually a bit easier compared to binomial because you don't need to calculate n times p and npq for your mean and variance. No such calculation. You just need to read off it. So it's even easier. All right. Just need to up to question. It's just the question interpretation that's difficult. After that, there's no calculation involved much. Same thing as the binomial for expectation. How about variance? Variance, just remember the formula. When you got 0.5 in front, you need to square it. 1.2 in front, you need to square it. And then you sub in the variance here and there. Is that okay?
Yeah.
Okay, now, good. Why do we want to calculate expectation and variance? Because that's what they asked for. Find the mean, which is expectation. Show that the standard deviation is 0.117, which is not correct. Why? Right. Oh, because that's only variance. You want standard deviation, which is square root of the variance. Right. So square root of the 0.0136. And you end up with 0.11662. Can?
Can.
Part 1 done. Part 2, find the probability that the total cost of the vegetables lies between 250 and 280. So that's very simple. Just P of 250 less than T less than 280. Okay? Which is what they have here. But you already know the distribution because you calculated the mean and variance. Also, we must present it like that so that it's very, very clear. They decided to write it as standard deviation square. So it's easier to key in into the GC. All right. This one, just use normal CDF and you will be able to get your answer.
Okay.
Oh, all right. Yeah, so maybe, yeah, okay. Then that's it for this discussion. Next, question 19. Oh my goodness, it's 28 already. Do I have time? Oh no, don't think I have time though. Okay, let's just read this. Thickness in cm of a mechanics textbook is a random variable with distribution n 2.5, 0.1 square. Part 1, the mean thickness of n randomly chosen mechanics textbook is denoted by n bar cm. Given that probability of n bar is more than 2.53 equals 0.0668, find the value of n. Okay, this is getting into sampling already. The next topic. The next topic along with hypothesis testing. This guy, n bar, is actually what do you call this? It is mean. The mean of the random variables. Okay, so you need to know what is the distribution. If x follows a normal distribution and mu comma sigma square, the x bar, the resulting mean of it, will still follow the same mu, but the variance will become sigma square over n. Okay, this can be proven. Not enough time to prove it. So let's just use the result. Okay, maybe I'll show it to you on Wednesday. Mu over sigma square over n. Can? So now we have to use that result. How? Okay. How? Put it there. Let's see. So we begin with writing down the distribution of the m first. Capital M itself is a normal distribution, 2.5, 0.1 square. Then what else we have? We also have the mean. Statistics textbook. Where got statistics? Okay, statistics is later on. You can ignore this. You cannot write this at the beginning. Just focus on part 1. Mean thickness of n randomly chosen mechanics textbook denoted by m bar. So here you need to calculate m bar. How do we do that? You need to use the standard formula here and conclude that m bar is n mean comma sigma square divided by number of books n. Not n square, it's just n. No square here at the denominator. Is that clear? Can?
Yeah.
Standard formula, I'll explain next lesson. Then after that, you realize that m bar, you want it to be what? They want you to have a value that's more than 2.53 equals 0.0668. So you just sub in now. You want to Yeah, given that. Okay. So now you can just sub in this guy 2.53, 0.00668. Okay, not sub in, just copy. Then from there you can do standardization, because why? Here you have a unknown. So whenever you have unknown in the mu or the sigma, you cannot type in GC, so you just standardize. Minus away 2.5, divide by the mu. Divide by the sigma. So the square root of 0.1 square over n, which is 0.1 over square root n. Then from there, you can take inverse norm, standardize. This one is inverse norm. Okay, then you get the 1.5001. Then from there, you can solve for n. Here, they just did a bit of algebra to simplify the fraction. Is it clear how to go from here to here?
Yeah.
Sure? Do I need to explain?
Why is it 0.1 over square root n?
Over here, this is your sigma square. This is sigma square. So that means you want to have 2.53 minus away mu divided by what? Divide by just sigma, right? Not sigma square, just sigma. How do you go from sigma square to sigma? Take the square root. Okay, so that means that sigma will be square root of 0.1 square over n, which is of course 0.1 over square root n. That's why it's 0.1 over square root n here. Is that okay?
Yeah, okay.
Can. Then after that, you just keep change flip. Numerator simplify 0.03 over 0.1 over square root n. Then after that, it's just 0.03 multiplied by square root n over 0.01. Right, fraction. Yeah, then after that, you get this, you can solve for n. Okay, then here you realize it's a decimal, but n is referring to how integer number. You see, a value of n is referring to n textbooks. So it has to be an integer, so you round off to 25. Is that okay?
Yeah.
Then I think we have to stop here, right? No time already. Or you want to continue finish the question?
Can
finish the question, huh?
Yeah.
Can now? Okay, I continue. Can. Next one, thickness of our statistics textbook. Just now was mechanics, now change to statistics textbook. Random variable distribution n 2.0, 0.08 square. Part 2, calculate probability that 21 of these mechanics textbook and 24 of these statistics textbook will fit onto a bookshelf of length 1 meter. Now take note, are these textbooks all the same? Did they mention 21 times of the same textbook?
No.
Or are they all different?
But they should be the same.
Nope, they are all different. Okay, thickness may not be the same. Random variable means what? Random. There will be some random error when the machine cut the paper, so the thickness may be slightly different. So that means all the textbooks have slightly different lengths, and here 21 mechanics textbook means they're all different. So what we are supposed to do? Textbook 1, if we use what random variable do we use? We use a letter m, right, to represent thickness of our textbook. So that means we actually need a m1, m2, m3 if we want the total, plus m3 plus m4 all the way. M20 then plus M21. You need to do this. You cannot write down 21 times M. This is wrong. This is correct. Are we clear?
Yeah.
A bit ridiculous, but yes, that is how ridiculous this question is. You need to come up with a summation notation. So I equals to 1 to 21, which is what they did over here. Okay, but they went a bit faster. They went a bit faster because not just 21 mechanics textbook, there's also N24 textbooks. They want to check whether it will fit or not. So we can just get the total length. That means M1 plus M2 all the way until M21 plus statistics textbook S1. Okay, here they wrote down the thickness of the statistics textbook already in terms of the normal distribution, 2.0, 0.08 square, standard deviation square. Then they just take S1 plus S2 plus ... until plus S24. This is what they mean by the total. They let T equals to. Is that okay?
Yeah.
And then it will follow a certain normal distribution, mean and variance. Then after that, you just want to find P of T being less than 1, less than or equal. But of course, this is normal. Again, it's continuous, so the equal sign really doesn't matter. So we can leave it alone. Don't need to put equal. relax the equality. Make the equality strict, inequality strict, but it doesn't matter. All right. Less than 1, then you can fit. If it's more than 1, then you cannot fit longer. So yeah, you have to state clearly the mean, the variance of any normal distribution you use in your calculation. Okay, so let's see what they did. So yeah, they just take the sum of the 21 textbooks and the 21 mechanics and 24 statistics textbooks. Using summation notation. No choice. This is not equal to 24 times M plus, 21 times mechanics textbook plus 24 times statistics textbook. It is not the same. Okay, good. So now we take expectation. Expectation will be what? Luckily for us, it's not so difficult. Just 21 times 2.5 plus 24 times 2.0. Because if you recall, the M and S distribution is at the top. Just use the mean, 2.5, 2.0. Okay, can? Good, now find variance. Variance will be what? Just lucky for us, this doesn't have the 21 in front, so it's just don't need to square that 21. I don't know if that's lucky or not, but you should also know that they are IID. So it means that all these follow the same distribution. So that means they share the same variance. So it's just variance of M1 plus variance of M2 plus variance of M3 plus until plus variance of M21, which means that there will be all 0.1 square, 0.1 square plus 0.1 square plus all the way until the 21st plus 0.1 square. So altogether it's 21 copies, 21 times of 0.1 square. Likewise for the S, 0.08 square, add them together 24 times. So do not square the 21 and do not square the 24. Is that clear?
Yeah.
Okay, good. You get this as your expectation and variance. Then you summarize. Summarize. Write down T follows normal distribution, mean, comma, variance. Must write this down so that it's very clear. Please write down. All right. Then after that, you want to find probability that the T is less than 100, not 1. Oh, right. The units. Right. This is in cm. Here they suddenly trick you by giving you 1 meter. You must make the units consistent. Since the random variable has always been in cm, this 2.5 is also cm. You just convert the 100 cm, convert the 1 meter into 100 cm. Is that okay?
Yeah, can.
Yeah. Good. Then after that, just calculate using normal CDF. Is that okay? GC, just use GC.
Okay.
Good. Part 3. Do I have time for part 3?
Can.
Okay, I continue. Okay, part 3. Calculate. Let me know if you need to stop really. Part 3. Calculate the probability that the total thickness of 4 statistics textbook is less than 3 times the thickness of 1 mechanics textbook. So notice the phrasing. They said 4 statistics textbook. It means 4 separate statistics textbook. So it's S1 plus S2 plus S3 plus S4. Okay. Then how about here? Total, that's why I plus. How about here? 3 times the thickness of 1 mechanics textbook. It means you actually need 3 multiplied by M1. Can you tell the difference? It's not M1 plus M2 plus M3. It's 3 times M1. Because they literally say times. 3 times.
Yeah.
Here, 4 standard phrasing. It will always appear in A-levels. It's their standard English phrasing, must memorize. 4 statistics textbook means you add them separately, because we don't know whether the statistics textbooks are exactly identical or not. So you cannot just multiply by 4. Must add them individually. Is that clear?
Yeah.
Okay, good. Now you want this guy to be less than this guy. Now state clearly the mean, state clearly variance of any distribution. So here you can, we say let D equals to, follow your style, just let D equals to this guy, then minus away, what is it? Is it minus? It's less than, minus away 3M1. If you want this to be less than, okay, maybe we should go the other way around to make things positive. So 3M1 minus away S1, S2, S3, S4, but we must have bracket. What does this give me? This will give me the difference between 3 times mechanics textbook minus away sum of the 4 statistics textbook. You want to make sure that the 4 statistics textbook is less than the 3M1, right? So that's why I want the probability. Can you see the probability in green highlight?
Yeah.
That's what we want. So that means that we just need to rearrange it and get something, some random variables on the left side, an inequality symbol, and a number on the right side. Let me just write it down. Actually, I just look at the solution. I think it's easier. Yes, you need this guy. Oh, they didn't put a subscript 1, so it's because there's only 1. It doesn't matter. You don't need to distinguish from M2 or anything. That's why they dropped the subscript. They subtract it away, minus 3m. Oh, yeah. No, they did it this way instead. Okay, fine. Is it right? Oh, they did it the other way around. Okay, that's also fine. They subtract away and then they calculate the expectation and variance. Do you know where they get these values from? Very
No.
simple. Okay, let's just call this D to make things easier. Okay, I get rid of my version. This guy gone. We use their version so we can write a bit faster. So this D is really just following this bunch of random variables. Here, this 0.5 is just the expectation of this D, which means that you will have expectation of S1 plus S2 plus S3 plus S4 plus, sorry, no more plus, minus 3 times of M. Now, this guy, because of linearity, we know what's the expectation of S1, right? And S2 and S3 and S4. And because of IID, we know they all have the same distribution, so they all share the same mean 2.0. Correct? And there's 4 copies, so it's 2.0 plus 2.0 plus 2.0 plus 2.0. In other words, 4 times of 2.0. Then now you have to subtract away expectation of 3m. Isn't that just 3 times of expectation of m?
Yeah.
But then you can just linearity, this is not variance, so the 3 factor out, no need to square. Expectation, don't need to square. How about expectation of m? What would it be? Look here, 2.5. Right? It's always mean, comma, variance. Mu is the same as expectation. Is it clear?
Yeah.
This guy is n of expectation of m, usually denoted by mu, and then variance of m, usually denoted by sigma square. All right, good. Okay, let's continue. So expectation of m is what? Let's see. What is expectation of m? It is 2.5. Oh, key in your calculator, you get 0.5. That's all. Expectation. Likewise for variance, this guy. 0.1156. You just do the same calculation. Is that okay?
Yeah.
Variance of the, okay, let's just see how to calculate this. So thing to take note is that this guy, variance of S1 plus S2 plus S3 plus S4, it is not 4 times of variance of S. Okay, is it clear? It's not 4 times. Sorry, it's not 4 square times. It is just variance of S1 plus S2 plus S3 plus S4. You split it up because they are independent. So you get variance S1 plus variance S2 plus variance S3 plus variance S4. But they are IID, they follow the same distribution, so they each have the same variance. S1 has variance, S1's variance, S2 variance, S3 variance, and S4 variance are all the same. So that means it's just 0.08 square. But you got 4 copies. Add them 4 times, it's the same as times 4. Yeah, sorry. It is times 4. It is times 4. But no square, no square. However, the next one you need a square. Because now you're gonna add on the variance of negative 3m. When you have negative 3 in front, what happens? Tell me.
Must put negative 3 square.
Very good. So that means that we will simplify this back down into negative 3 bracket square. Oh?
Yeah.
Okay, good. Then what happens when you have negative 3 square? It's just 9 times. So 0.08 square times 4 plus 9 times of variance of m. What is variance of m? 0.1 square, okay? Like this. Is that clear?
Yeah.
Okay, very good. Then key in the calculator, you should get 0.1156. Yeah, they did all this without any working. Yeah. Do you get 0.1156?
Yeah.
Yes, very good. So I hope it's clearer now. Must always find expectation and variance and summarize. Here they just jump straight to the summarize because it's kind of simple. Okay, then after that, what do they want? They want the probability that the total thickness of the four stats textbook is less than the three times mechanics textbook. So if you take S1 plus S2 plus S3 plus S4 minus 3M1, this will become less than 0. Correct or not? Oh, you need these guys to be less than that guy. If you bring it over, plus 3M, bring over, become minus 3M, right hand side become less than 0. Is that clear?
Yeah.
Very good. Then you can just use the GC to calculate using CDF. Oh, normal CDF. You already got the distribution. Make sure you always summarize the distribution so you can solve it. But also a very important point to take note here is, here they mentioned for statistics textbook, you have to write it as S1 plus S2 plus S3 plus S4. You do not write as 4S. Are we clear on this?
Yeah.
English phrasing must memorize on, no choice. But for 3 times of one mechanics textbook, sometimes they won't even tell you one mechanics textbook. They'll just say 3 times of a mechanics textbook. So you have to be, it's just one letter and you need to know it's 3M already. Okay? Make sure you know the difference. It is not M1 plus M2 plus M3, and is a minus here. Yeah, then as a result, you need the square there. Okay? Can. Alternatively, you could have also used what I wanted to do initially, which is a bit slower, S3M minus away bracket S1 plus S2 plus S3 plus S4. This is a bit more problematic because you now need to distribute the negative sign, which requires more work. You'll get the same answer, but then your final answer will be P of this guy more than 0. I'll just change the direction. Is that clear?
Yeah.
Can yeah, this is also okay, but be careful of minus sign. Okay, very good. Moving on. Part 4, last part. I think we have to call it a day. Huh? Okay. It's a binomial. There were some questions I haven't go through also. Part 4, state an assumption needed for your calculations in parts 2 and 3. Independence. Independence. Always independence. Almost every time. Not always, but like just now about the S less than 0 one. But usually it's just independence. Must assume distributions of the widths of all textbooks are independent of one another. Not just the width of mechanics textbook must be independent of the widths of statistics books. Okay, all the textbooks within the mechanics themselves, mechanics number 1 textbook, mechanics number 2, the second textbook, their width must be already independent of each other. Basically, all the textbooks are independent. Can? All right, can. All right. One more thing I wanted to bring up is about the binomial one. Over here, there was this question, right?
Yeah.
The basic idea behind this is that you're trying, it's a very long-winded way of finding the mode. Most probable means find the mode, which means you go and use the table function in GC to get all the probabilities, to get all the probability values. But take note of the year 1982. Probability values are. Then from there, using a GC, then you scroll until you eventually find the place where there's the highest probability.
Oh.
Okay, it's like constructing your table of values. Remember, we did something similar.
Yeah.
Like we have to go through a row. Then, yeah, you need to calculate the PMF. Oh, sorry, should be column here and then M here. So you list down all of the values. That is the GC way, but take note that this is a question written in 1982. So no GC yet. So I think so. They don't allow GC yet. They tell you to show this part here. What are they trying to do? they are trying to get you to realize that a binomial distribution will look something like this. There will be a bunch of lollipop graphs. Okay, if you plot x as the possible values that x can take on, and then y-axis is the probability that x is equal to m, you'll get a graph like this.
Oh.
Okay, just all these values you plot as the y-axis, and the x-axis is all the different indexes, all the values. Then what they want you to realize is that x equal k plus 1 over p of x equal to k is comparing the height of the right triangle versus the left triangle, versus the right and the left. Now, if let's say that I give some imaginary, not complex, I mean, pretend that there's these numbers. This is 1, 2, 3, 4, 5, 6. Then we have 0 0.1, 0 0.15. This one may 0.2. Maybe this one 0.15. Maybe this one 0.3. Let me calculate first in my head. In my calculator. 0.75 already. Then 1 minus, and I get this guy 0.2. Okay, that's not very accurate. Let me think a little bit. I need to share some values over. Oh, maybe I'll chop this off. I'll get to get a 0.1. Maybe I'll share some values here. This will be 1.7. Then it will be a 0.03. So it's like a 0.155. That's still not very accurate, so I'll just swap these two, I guess. Is it in order? Not exactly. This is 0.17, this is 0.155. Sorry for the mess. Okay, 10. So what you realize is that these values they are in that particular order, 0.1, then 0.155, 0.2, 0.225, and then drop down to 0.17, and then drop down to 0.15. Oh, so you realize their sum is equal to 1. Oh, that's the what I call lollipop graph. Because what was presented to me when I learned it was lollipops like this. It's just a bar graph. Okay, then this is a lollipop graph that's really just like a distribution. It's what we call a distribution. Right? You have a table of values, x equals to m, like the table of values, x equals to m, then p of x equals to m. You have 1, 2, 3, 4, 5, 6. Each of those probability values, 0.1, 0.155, 0.2, 0.225, 0.17, 0.15. Okay, then this question is trying to get you to realize that there's a formula for it. P of x equal to k plus 1 versus x equal to k is like, if k is equals to, let's say for example, k equals to 3, that means that p of x equals to k plus 1 will be 4 over p of x equal to 3. What you realize is that 4 is taller than 3, right?
Yeah.
So it will be 0.225 over 0.2. That's just for example. But the more important point is that big over small will give you a value that's more than 1. Correct or not?
Yeah.
Okay, good. So if you actually compare, if let's k equal to 2, k equal to 1, if k is equals to 1, you'll be comparing 0.155 divided by 0.1, which is also more than 1. If k is equals to 2 now, you get p of x equals to 3 divided by p of x equals to 2, which is 0.2 over 0.155, which again is more than 1. So the trend here, you realize is that every time you compare tall with short, you get more than 1. The next one, k increase, tall with short, more than 1. Tall with short, more than 1. But the moment you reach the maximum value, you compare x equal to k plus 1 to x equal to k. Okay, now no space. If example, k equals to, let's say 5, right? No, 4, sorry. K equal to 4. We will end up with p of x equal to 4 plus 1, which is 5, divided by p of x equal to k equal to 4. This will be 0.17 over 0.225. I don't care what the answer is. More importantly, it's small on the top, big at the bottom, which means the fraction will be less than 1. Can you see that? So the main idea here is this expression is giving you a formula to calculate this ratio, this ratio. When the ratio is more than 1, you are increasing. When the ratio is less than 1, you are decreasing. At the point when you increase and decrease, what do you call this? The maximum point, right?
Yeah.
You can see or not? And that maximum point is the place where there is highest probability, most probable, also known as the They should. Well, okay. Here they say most probable number of success. It's really just finding the mode. Which means the answer they're looking for if this was the actual example. I'm just coming out with a random example here. The mode would actually be 4. The moment you notice the change, 4 to 3 versus 5 to 4, more than 1 and less than 1, it implies that mode equals to 4. Is that clear?
Yeah.
That's the purpose of this question. But of course, that's with a concrete example. You have to do it in general over, actually also not in general, because they gave you an N, they gave you a P. Oh, but this question is very outdated already because we don't need to do this. Okay, we don't need to use the ratio. We have a GC to do it for us. We can manually calculate the x equal to 1, x equal to 2, x equal to 3, and then after that you just look at the table of values. Right? Of course, this is the graphical way to represent it as a bunch of lollipops. But of course, usually in a GC, it's row by row. You realize there's an increase and then suddenly a decrease in the value. Then that point where there's the highest value of the probability would be your mode, the corresponding x value. If you remember this kind of question we did before for binomial. Yeah. So this is just giving you an alternative method without using GC. Hence, you have to without using GC. Is that okay?
Yeah.
One more point. You asked me, need to give reason. No, don't need. Okay, if you want a reason, it's because over here, if you take a look at this expression, just I take a screenshot of whatever you wrote down. What you realize is that if P was equal to 0, what happens to this expression here? Zero, right?
Yeah.
If P equals to 1, what happens? There's a 1 minus P here. So 1 minus 1, which is 0. 0 power 4 is 0. Times anything times 0 is 0. So that means that your P of x equal to 2 will be equals to 0 again. Would that be possible for x equal to 2 to be 0?
No.
Not really. Probability, usually we won't want the extreme cases of 0 or 1. Okay, and anyways, here they mention proportion P. 0, if P equals to 0, it means 0%. P equals to 1 means 100%. I don't think that would be really realistic, right? Practically speaking.
Yeah.
Proportion P of defective items cannot be 0% or 100%. Unlikely. Okay? Can?
Can.
Okay, then that's all I have for today. Homework. You're doing hypothesis testing, is it?
Yeah.
Okay, can just continue. Okay, you need to rush off, right? Okay. I think.
Is there anything else?
I'm thinking because I haven't really reviewed with you hypothesis testing, the theory. Then I give you homework a bit. Can you do it or not?
Trying. I only had question 4.
Okay, and actually, I think it's actually better if we do sampling before we do the before we do hypothesis testing, because you need to know sampling before you do hypothesis testing. So can did I go through with you before?
No.
No, oh no. Basic. Oh no. Basically, sampling is these kind of questions. Let me show you. It's again normal distribution, but you need to learn the new thing, X bar. Magic formula X bar. I already mentioned just now, if X follows normal distribution, mu comma sigma square, then X bar will be following the distribution N, but same mu, but sigma square need to divide by N. Also, if you have sample size N equals to, like, let's say 30 or bigger, we have something called the, what is it called? CLT, stands for what is it? Central
limit theorem.
Central limit theorem states that if you have let's say a different random variable y that follows question mark distribution, okay, we don't know the distribution. Let's say it's continuous. Actually not just continuous, it can be discrete. But let's just say that we don't know the distribution. Okay, it's not normal. We don't know. However, if the sample size n is very big, then that means that the y bar will converge in distribution to follow a normal distribution with mu comma sigma square over n. So it's very, very close to the actual x bar here, where x, if this guy, this is version 1 without CLT. When you already know x itself is normal, x bar will of course also be normal because you take the sum then divide by n. What is x bar? I haven't defined yet. X bar is supposed to be sum of all xi's, I equal to 1 to n, then divide by n. I'll explain that next lesson, I guess. Then after that, you can you will definitely get a normal distribution again. But for CLT, it starts off with an assumption that another random variable is non-random. We don't know what it is, but we know its sample size is very big. Then from there, we can conclude y bar, the mean, the mean, yes, it will be converging in distribution towards a normal distribution, which follows the same formula, okay? All right, those are the two things. And also you need to know how to do this kind of question, which is very similar to what you have been doing. The 3 times versus adding up individually. What else do you need to know? You need to know, what's that fellow? Sorry, lost my train of thought. What was that guy? You have to go and know how to calculate the sample population, sample mean, and the sample variance. Yeah, sample mean and sample variance formula. If I can find an example. This kind of question. Unbiased estimate of population mean and variance. Do you know these questions?
Yeah.
Yes, huh? Okay. You know what? I'll make a recording of a video for you, or maybe I find some YouTube playlist to explain this idea. Plus to explain this idea, because there's some subtlety you need to know when you're doing this kind of question. Okay, so I actually don't want you to do hypothesis testing yet. I want you to do sampling first, because it's required knowledge before you can do hypothesis testing. If not, it's going to be very slow. You don't know, then you don't know something here, then you go and do hypothesis testing, not efficient. All right, Ken, then that will be all for today. I'll send you the file later for sampling.
Okay, Ken.
Okay.
Thank you.
Thank you. Bye-bye.
Bye.